Let me pull my microphone up over here. And got a few other things to pull up here. All right. Let's go ahead and transition over to this. So I've got, let me cancel that real quick. Get rid of that. Good. There we go. All right. You guys should be able to see my screen. And what am I working on right now? I am working on some other stuff, and it looks like people are already hopping in there, so that's good. So we've got a couple of things going on in the system tonight. I'm going to be working in the lab environment, doing some work, but I thought, I haven't been on for probably all week, so I thought I'd hop on and kind of hang out with anybody that wanted to chill, do a little bit of Linux, doing a little bit of hanging out. Yeah, so speaking of Hacker Man and stuff up, I might be putting together, I told the guys that I would pull this thing up, so, oh, also, if you guys want to chat, you can chat here. Right, so if anybody is in our Discord and wants to hang out and ask questions, you can even ask the bot things. Ask, how is Linux compared Unix? That kind of stuff. Oh, shoot, that's funny. All right, anyways, you guys can talk to the bot if you want and all that good stuff. But I'm just kind of hanging out, not working too hard. But you guys are welcome to kind of hang out and interact a little bit. I thought what I'd do too a little bit is have just some of my lab stuff going. I might be kind of keeping my systems running. We need to keep an eye on, how everything's running in the environment. So we'll probably have some logs kind of keeping up over there as well. And then I'm kind of munching on some stuff over here too. So, if you guys have any questions, let me know. Otherwise, that's kind of what I'm working on. I have a fair amount of just stuff to catch up from work, but also I might be doing a little bit of this as well over here in this window. I might also be pulling this up and going over to my GitHub. I had some stuff that I'm supposed to be reviewing. Let me find it real quick. Let me go find the stuff I'm supposed to be reviewing for our project in the group. So give me a second here. When I get that, I'll show it to you guys. Let me see if I can find that real quick. I think I got it right here. And I think course syllabus for this should be the security. Okay. Yeah. So this is the link here. Copy. Could drop it over here. And basically I need to update what the course is going to look like. Totally read that as Hackerman. Oh, Hackman. Oh, no. I should be good. Well, for the most part, I'm good. I've been super busy with work. In fact, as I got on here, I realized I have more work to do. So I have quite a bit of things to do. So I was going to be on most of the night, but then I realized, well, maybe I'll work on that stuff as well. But yeah, I'm kind of hanging out. Just got a lot of stuff. It's the end of the quarter for the college. Yeah, you guys should be able to see all that stuff up there too. Okay. So what I need to do is probably go grab my course outline. Shoot, I don't even know where that is anymore. I've got to go find it. All right, I'll use this. And I think I'm gonna, instead of going too far afield, I think I'm gonna go. I think we're just gonna do securing Linux. I'm not gonna probably have the time to do the compromising side of it. So we'll do it. We'll do this one as 8 weeks, and then we'll do another one later, which will be compromising Linux. It'll be the other side of the security. But I think my weeks are good, except I got to get rid of 9. No, maybe we'll keep it at 10 then. That's fine. That's fair. We'll do 10 weeks. And we'll say securing Linux, and I'm going to do a preview. And that doesn't look very good. So, what am I missing here? Unit 1 looks fine. Unit 2 is too indented. What was happening there? That's interesting. Oh, I think I know what's going on here. All right, we need a space. Let's see if that's better. Yep, that's better. Okay, need spaces. Markdown cares. What happened? I don't think it's just tiny. I moved to CSO role and you're taking security course. No, ops to dev. I'm writing a security course. I'm working and I'm actually doing. I am actually going to start working on the doctorate again in May. So I have a little bit of a break and then I'm going to go back to working on the doctorate. Doctorate's going to change a little bit. Some of you guys that remember what I was doing, it's going to be a. The degree is going to be in, it's going to be a PhD in systems engineering. So that's what I'm going to be focusing on. I had been doing a DBA with an emphasis in quantitative analytics. And then I kind of had a little bit of falling out with my college, which had just, it had everything to do with the way that they handled something. So I don't agree the way that they handled something. So, all right. I'm going to update this. Boom. We'll just say that this will be just the security side of things, or just the securing Linux side of things. That's what we're going to be working on for that part of the project. I'll come back over here to the Excalidraw. You guys have the link to the Excalidraw if anybody wants to draw on it. That's over in the Discord, but you do have to be down in the Discord on the Twitch schedule if you want to talk in there. So, yeah, it should be good ops to dev. I think I'll be fine. As I sit here and munch on my Girl Scout cookies. All right, let's check how our system's doing. All right, so one of the things about Werewolf, when you go look at all your nodes, right, you should be able to hit any node in the environment. So let's just say Hammer 24, right? I should be able to hit that, And then the other thing I need to do in my nodes here, so let's vi Etsy Ansible hosts, right? And in this file, we have Rocky and hammers. Okay, so we do have, I did add all those in. So if I say Ansible all, and then -m shell -a uptime, I should be able to see everything in my environment right here. This should be a pretty straightforward little Ansible command. That'll just go and hit all the boxes. Now, I don't like that. I'm going to hit Control C. Now, Ansible by default is only going to fork 5 times. So you'll see the response. If we do this again, you're going to see the responses in 5 server at a time increments. And we don't really want that. We've got 44 nodes, so we're going to fork out to, like, let's say 16. So hit 16 nodes at a time, and this, you'll see them come back in larger blocks. Okay. So our nodes have all been up 17 or so days. Let's go check real quick down in this environment. We can also go to Ranger Cam. Check on Ranger, how he's doing. He's not on his bed right now because I fed him a little while ago. And then also, we wanted to do, what's the other thing? We were checking on Ranger, and then also, let's go to our logs in our environment, and let's see, we can get messages, but can we get hammer? So are the hammer block nodes respond? Yes, they are. Okay, good. So we can see both the messages and the everything else. So if I undo that, we should be able to just kind of sit here and monitor what's going on in the environment. Also, I should be able to come over here and do another logs and watch just the regular secured failed. These are the logins and attempted logins to my system. So now I can let that just rotate. So there's our hammer block. That's the home lab environment there. And then this is, yeah, so we got all that stuff on the screen. You guys can see it all. I could probably get rid of that. We can kind of monitor the environment as we kind of hang out here. So yeah, so that's what I've been up to. I've been super busy the last few days. I've been working late into the night. I kind of getting servers pulled up, security stuff. I do a lot of security stuff, and we can just kind of monitor the environment as we're doing all the other things that are kind of happening over here. Yeah, we've had some good successes, by the way, too. Some of the guys in our group have went and gotten themselves new roles. One of our guys just got hired for a sysadmin type role. It sounds like a few other people have been looking. So that's good. You know, people are focusing on stuff and moving. We have, if you're ever in a Discord, if you guys don't know this, if you're ever in Discord, at the top left of the Discord, you can always find the events that are coming up. So in our case, we got the writer's room tomorrow. It'll show it in your time zone. So it won't just be it won't be just 12 p.m. like it is for me. It'll be whatever your time zone is. And then we have a weekly meeting tomorrow. I just put this on the calendar, so there's not too many people on there yet. But people that want to come to that, we're going to kind of start hanging out. I'm going to turn that. I'm going to start working on turning that into like an operations bridge. Have any of you guys been in, most of you that have done admin or engineering work, you guys have done at least like the most basic of like stand-up meetings and stuff, right? But have any of you guys ever been on like an operations daily stand-up? How's it going, Camby, over on the YouTube side of things? Yeah, I'm just kind of hanging out. I'm going to start turning the ProLUG weekly meeting into kind of a state of the system. Like how many systems are up, if we experience any major P1, P2, P3 type outages. And I'm just going to start running that like a operations bridge daily stand-up type call. I'm just going to do it as like our normal meeting. So if any of you guys want to come and see like what an operations stand-up meeting might be like, or what you might run into if you're doing systems work, specifically operations type work, and trying to keep the system running, some operational system for a company, I'm going to be kind of working through that stuff with you guys. So for people that are interested in that, that's coming up. And then this is also important. The new Linux sysadmin course is starting March 22nd. We don't charge anything for that. That's just for people that want to join our Discord. Discord's very free. I'm going to link it over on the YouTube side. So I put it over on Twitch, but it's also on the YouTube side right here. So you guys are welcome to kind of hang out. And Blade Tools, thanks for the Prime. I definitely appreciate it. You guys are welcome to, you can use those anywhere, but if you choose to use them here, that keeps you from seeing ads, which is kind of cool. So, yeah. But the Linux sysadmin course, we've never charged anybody anything for that. This is our second time running through it. And some of our guys are putting together, the original way I ran this course, if you go in the Discord, I just kind of threw it all up there, right? Like every week we added more and more pieces, and you just kind of grabbed them out of there and worked through on each of our Saturday meetings. But now the guys are putting that together as a book. So that's going to be just a GitHub book that you guys can grab. And it's just going to be like systems admin stuff, start to finish. And if you come through and do it with the group, right? If you do the 16 weeks with the group and you actually participate in all that kind of stuff, we have a nice little set of, you get a little certificate for completing it. So some of you guys finished that last time, and people liked it. So that's anyway. So that's kind of where we're at there. Let me go back to where I was. You guys are welcome to, again, if you want to talk in here. Actually, I'll probably jump down to YouTube questions. So talk in here. You guys can talk in there for stream tonight if you want. You guys are welcome to hang out and ask questions. Let me know if you have anything that's not working for you, or stuff you want to hear more about, and that kind of stuff. Sometimes I jump down in the Discord as well, but I think that might be distracting for some people, so maybe I won't do that tonight. And when I say some people, mostly me. Also, it's on a back window, so let me know if Ranger pops up again. All right, so got that. Let's go look for, where's our werewolf stuff? Yeah, let's go. We'll just keep an eye on werewolf, making sure it looks clean in the environment. So that's what you're seeing on the left side of your screen there. That's werewolf has a log that just kind of tells you when the nodes check in, when they pull stuff down from TFTP, and that log is super useful for, like, is a node checking in? Is it getting its newer updates? Are there problems with the system? Because if werewolf's not properly serving those out, this log won't show things correctly. But it shows that we can talk to nodes. It shows what hardware addresses they're using to come in, and then what their actual addresses are. So there's a lot of good information that you can kind of get from just watching that log. Would I tell you to keep that log up all the time on a working system? Probably not. But when you're building a system and you're like making sure nodes are coming back up, and you're making sure that they work, that they're booting properly and pulling the right version of the image that you expect, this is a perfectly acceptable thing to kind of keep an eye on. Right. Here's a fun one for some of you. When you see a hardware address like this, right? You see that one, you see that one. And you see all this variability in the hardware addresses. Does anybody know why that tells me that I am very likely in this environment dealing with virtual nodes? Does anybody know how I know that? Well, I mean, obviously I know that because I built the system. But I'm saying, if you were a new person in here and you were just being presented with this file, and it was rolling by, and you were trying to glean whatever information you could, why might you know that this is probably a virtualized environment and not a hard set? Like, it's not like an all Cisco or an all Dell system or that kind of stuff. Blade Tools, you've been looking for a channel like mine for a long time, trying to get in DevOps position currently. Thanks for content. Greetings from Brazil. Well, you're welcome to hang out. We have a Discord. We have quite a few people in the DevOps world. I focus heavily on the Linux systems in my world and the securing of those Linux systems. Securing them, automating, and building them out the same way. You'll see me do a lot of that stuff. On Fridays, we just kind of hang out. YouTube, over on YouTube, said, "Hi, Het, what's the purpose of the added Hammer virtual machines?" Well, I was going to run, in this new version of the course, I was going to run the Hammer block environment. I'm not saying we're not going to do that, but I might do less of it than I was going to. But the added virtual machines are this environment for you guys to be able to play around in, basically. So if you look over here, here's the Hammer block range on the, whoops, make that thing stop spinning. This is the Hammer block range over here. Actually, it's funny. I am very sure that I had saved this, but it's funny. Oh wow. Okay, so I need to fix this. Hold on. We're not going to end up doing a new werewolf because we actually did it all, and this is actually built or finished, right? This Hammer block range. And these nodes, yeah, these nodes actually just belong with this. As far as that goes, it's all off of this original werewolf. And then this lab network is all VLAN 1 in my environment. So all of the nodes are there. Anyway, so the Hammer block range is this ability to go and mess up. Can be said from the OUI. Yeah, so in here, in the, the first 24 of your 48 digits. So you've got 48 bits in a hardware address, right? So I'm going to stop this from spinning. You've got 48 bits across here. They're hexadecimal. So like 7 right here is actually 0, 1, 1, 1, right? That would be the number 7. And then this E right here, E would be something like 1, 1, 0, 1. That would be, no. 1, 0, right? That would be E. And then C would be, anyways, the point is you've got 48 bits across here, guys. And the first 24 of those bits are the organization that made the servers, right? What gets stamped on there. And then the second half over here is like the unique for the individual device, right? So what the point was, I think that Camby was mentioning is, yeah, if these were all Cisco devices or these were all like Dell Ethernet for their type of server, these would all, the first part of these would all be the same in an environment. The fact that they're so different like that, I mean, these are dramatically different. 0E, 0E, 82, 7E, 42. Like, I wouldn't even think these were in the same classes of, like, you know, Cisco devices or anything. This is massively different over here in this half of the address. So that leads me to believe that they're just auto-generated, which is something that's very common in virtual environments. So in virtual environments, you would expect to see these numbers, the first half of your hexadecimal that makes up your hardware address, which is the first 24 bits. That's the they are dramatically different, so that's how I would know. So that was the question I had asked earlier for people that got here late. Was I said, how would you know by looking at this that it's probably a virtualized environment? So Hammer is just a naming scheme for the, yeah, YouTube, that's all it is. Yeah, the Hammer machines are just added. It comes from, so if you're wondering where it comes from, we used to have Me and some of the guys that used to work at Lockheed Martin, some of the engineers that you'll meet around if you hang out in the Discord long enough, some of the guys that worked with me years ago, we had this testing range, and there were these competitions called hammer block competitions, and you would just go in and basically do ratchet stuff on these systems. And ratchet's a lack of a better term. You were allowed to do whatever you wanted. It was a full open warfare range against the nodes that were there. You could do literally whatever you wanted to them. Hey, Paul, how's it going? Man, I haven't seen you in a while, Paul. You know, I'm on bachelor pad status tonight. I don't know what you're up to, but so you guys that don't know, Paul lives in Phoenix like me. The wife is up visiting the grandbaby who had his 4th birthday yesterday. So, yeah, the grandbaby's 4. So, you know, that's fun. He's a good little guy. So I had a virtual pizza party with him last night. I had pizza here, and then he had pizza up there because he really wanted cheese pizza. So, and it all costs money. How's it going? Yeah, we're just kind of hanging out. You know, we don't work too hard on Fridays, guys. I can pop on stream here in a little bit, but I'm just kind of hanging out as I'm warming up. I haven't streamed and this is probably the longest break I've taken from streaming since maybe the last time I was in Mexico. And then probably besides that, maybe since I've ever started streaming. Like I think I've been almost off a whole week right now. So it all costs money. You've been using ChatGPT to help you planning with your home lab setup. What's it been telling you to do? Also, by the way, guys, if you go in here, which is the Twitch, YouTube channels from stream, or questions from stream, you guys can talk on here if you want, and it'll pop up on stream. Well, as long as I have it up where I'm looking at it. But yeah, so you guys that are part of the Discord, or if you join the Discord, you can go in there and talk all you want. It'll pop up on stream. So, yeah. So back to the question though. Hammer Block was a name of a competition, and my team took 1st and then 3rd out of about 400 teams at Lockheed Martin. So, yeah, there we go. Yep, it should pop up there. Enzo Bear, how's it going? It all costs money. It's giving me all the setup and wiring to set up VLANs and VMs. What are you gonna do with it? What are you gonna do with your home lab environment? Is there anything particular you want to do? It all costs money, or you just want to build Linux systems and blow them up, build them and blow them up? Which, by the way, I think is one of the most valuable things you can do if you're trying to get into the industry. Is like get in there and just start working, guys. Like I tell you all the time, like if you're not doing any Linux at all, you're not doing any right now, anything is better than what you're doing. And then after that, you know, we start thinking about, well, where do I want to, you know, what after that, then we end up having to maybe look at, you know, once we start getting some proficiencies, where would we best spend our time? And I would tell you for sure, automation and security, both of those topics are going to pay dividends for you in a career where maybe you track things. Monitoring, I think monitoring will be definitely valuable as well. You know, knowing how to put together even like the little monitors that I have, lots of value, I think, to a company, right? Because we talk about it as engineers, and I've shown you guys this before, but it's like, what's the value that we bring to a company? Why would a company want to hire us as an engineer or an admin? Well, as an admin, they want you to keep their stuff running. And as an engineer, they want you to build new stuff that solves the problem, and they want you to keep stuff running. Those are the two things they want engineers to do, right? Admins and some other stuff. Cambia, you said, what are your thoughts about the new Mozilla Firefox terms of service? Do you think if a company happens to have Mozilla, if it's going to affect folks like Libra? I haven't, Mozilla Firefox has a new term. I don't even know what it is, Camby. I very rarely in my environment use Firefox, except for, I actually use it as a third, third type of browser. I use Edge and Chrome, and then I have Firefox because if any of you guys have ever authenticated, God, man, once Microsoft gets in and you have to authenticate to like a company or something, and then they have Okta, and then they lock all of Okta behind their tools, then you have to open a whole different browser to do anything else, and that's kind of my reason for using multiple browsers in my home system. So It all costs money. Eventually, I'd like to get comfortable enough to start my own game file hosting company in my area. Nice. Nothing like it here, and we have primo internet. Interesting. Yeah, yeah. That's a good goal. Getting some and then private VPN, game server hosting, Steam backup, and OS file backups. Okay. Okay. I think all of those are good. I do all of those things as well. I do backup of my home lab stuff into a Linux box on my home network. So I think that's very valuable. Can be. You said the reason I'm worried is because I run LibreWolf in my distribution. I don't really want to change it. Yeah, I don't. Yeah, can be. I wish I stayed more up on some of that stuff. I don't even, like, most of the time I very rarely even have time to spend. Like, I don't do as much, like, keeping up on trends, even with, like, desktop stuff as much as I'd like to. I mostly just spend most of my day down in the server world, head down, building stuff, you know. In fact, I spent a good part of today working on security for a company. We have this, I wouldn't call it a side project. I'm kind of on, like, right now, so some of you guys know I'm kind of in flux at my company right now. I'm going back over to NOAA, which is the National Oceanographic Atmospheric Agency, but this is within my company that I already work for. And they have me at kind of right now I'm on this team that just basically we just do jobs and then close out work for Dell. We're like a subcontractor to a bunch of different Dell projects, and I've been building out stuff for different government customers. And I got one that's due. We're trying to get most of the stuff done by Monday so that we can have jobs running in the schedule on the HPC system by Wednesday. So, like, lots of stuff. I'm gonna be working a good part of this weekend as well, which is fine. Like, I'm salaried, so I don't really care when I work, you know. Gives me a little bit of leeway to mess around during the week and stuff, but I'm also kind of busy. It all costs money. I'd rather be able to just one-to-one copy a backup. Yeah. You don't want to reinstall Windows on your PC every time you break something. Yeah, fair enough. Enzo Bear, you're still waiting on a data center job off? Nice. They said they're still choosing the candidates, and we'll know. Yeah, that's the worst, man. Enzo, I hate waiting for stuff. I hate waiting to know. I hate that kind of stuff, especially if there's only one position and they had a few candidates that they liked, you know, and then now you're sitting there waiting. Oh, there's a lot of positions. Well, that makes it a little easier then, hopefully. It's nice if you can get in, because I tell people all the time, you know, and this is a shitty way to think of it, but it's very true. Like, to be better than 95% of people, all you have to do is show up and not complain. They're hiring 17 and there are 20 applicants. Well, see, then that's good. Because here's the thing, of those 17, maybe they end up transitioning a certain amount over to real people, you know, to real, like, employees eventually. And you sit around and you think, man, all I got to do is show up on time and not effing complain. And seriously, that beats most people. Then I talk about the other 5%, and you say, well, how do you beat them? Well, they figured that part out, so now you just have to be good. So, all cost money. Said you put my router behind a layer 3 switch and using it only for Wi-Fi and plan on running pfSense VM. If my DHPC server is VM, how does that work when I restart or lose power? Yeah, so, well, it all costs money. If the DHCP server is on a virtual machine, then, well, so that there's a couple of things to think about this in server world. In server world, right, like in places where I live, where I build servers, all my servers are statically assigned addresses. I like to statically assign things. Now, that being said, your DHCP server should come up and he should have a static address, and then he can start serving to the other devices, like a Werewolf device. It's funny, Werewolf is doing DHCP, but it's against a static list that we already have in the nodes file, but that's neither here nor there. The point is, DHCP does have to come up before the other devices. Now, if devices come up and they don't have information yet, they will keep sending on DHCP until they do. So as long as you only have one DHCP server in the environment, that's fine. You're just going to have nodes that don't work until it comes up. So, It all costs money. This is an important, I guess, lesson for you to think about if you're going to build something that's substantial in your home lab. This is my advice. You are going to be basically you're going to be undertaking this idea of you're going to want to start to build out what we call like a run book. And a run book for your environment, this doesn't have to be formal. This doesn't have to be any more than like a basic understanding of maybe your run book is even just a notepad for yourself. Notepad++ works fine. But the idea is as you run into things like this where when you start the system certain things don't start, then you go, okay, oh shoot, that's busted. I need to remember that in the future, and then you add it to your run book. And then your run book is just basically a set of procedures that help you to run the system and keep the system operating. And all good run books have a startup from bare metal procedure. They're the order of things that turn on, how long things take. Hey, bare metal to start up in my lab environment is expected to take 15 minutes. That's a good thing to have. Because if you have that in an environment, what you can then do with that is feed that up to management. You know, you got a change window where you have to maybe turn some stuff off. Then you can say, well, yeah, you know, we know from the run book that this part of it only takes about 5 minutes to come back up. Okay. And then the business, this is a thing I tell you guys as engineers, we're not in the business of making business decisions. We're in the business of doing good engineering, right? So then I can turn around and tell that to the company, and the company can be like, oh, yeah, no, that's right. That is what I should do. I should follow that advice because they've proven or they have a track record of giving me good information, and then I could go make good decisions based on it. Hopefully that makes sense. But yeah, that's what I would say. It all costs money. Is just you're going to learn how your system boots up, and then I would start to build a run book out. In future versions of like the Linux sysadmin course, I'm definitely going to focus on what we call build books and run books. Build books tend to come from engineers, and they're how a system is built, and then run books are how you operate a system in real time. You know, so I actually thought that would have been a good project for people that were doing for anybody that did our Linux sysadmin course. One of the things I was going to say was giving somebody access and having them build out the run book for our lab environment. It all costs money. I'm used to it in the smaller lab environments. I just let the device be the DHCP, the device that wants to, which tends to be your internal interface of your router. But that being said, a DHCP server doesn't matter if it's physical or virtual. It doesn't matter as long as it's there and feeding on the network. Like in my lab, hold on, I have Werewolf. If you guys haven't ever seen, Werewolf has a whole bunch of things defined, and one of the things that are defined by default in Werewolf is whether or not he's the DHCP server of his environment. So the DHCP server is enabled, it's got a template default, and then once you build this, Werewolf will go and set up your DHCP information. So here's all the DHCP stuff that's actually auto-generated by Werewolf. And where did it come from? This is actually the overlay where on the main host we can do that. So we can modify the behaviors of this and then rebuild and reconfigure Werewolf. But yeah, this is really it. Here's our subnet with our net mask. Make sure that's always correct. Max lease time is 1 minute, and then the range is this range to this range. I could modify this if I need to. And then the server that they're going to go to for that information is this one here, right? So, because this is the Werewolf server. So, yeah, DHCP is like very simple. You can have clients and tools that'll build it for you. Werewolf does it itself. All you got to do is go and set it in your Werewolf config up here. And then I should be able to see. All right, so there's our DHCP daemon. It is doing things in my environment and responding to nodes that need to know stuff. And on also down here, I should be able to ss-ntulp grep-i for DHC, and then I should see that my system is listening for DHCPD. And there it is, listening on 67, right? There's its process ID 142218, and that should map to this. It does. Yep. And then all the different things that we can kind of do from there. Z Franca, you said the sysadmin course occurs on Discord or Twitch, YouTube. So here's the things about the sysadmin course. We do run it out of the Discord, and we do meet. So when it starts, it'll actually be in the Discord, right? And the way I did it last time was like this. We did it on Saturdays, right? It's Saturdays, 3 p.m. my time, which will be whatever time it is your time. If you're in Discord, this will automatically be your time. And then the day after I did this, so basically I recorded these every Saturday we met, and I don't record the meetings. And you might say, Scott, why don't you record the meetings? Wouldn't that be really good? And I say, yeah, but people won't. When people are being recorded, whether presenters or people in a classroom, if they know they're being recorded, which, by the way, I don't want to lie to people, so I'm not going to tell them that we're not recording. But we're not recording, so just know that. And people will be a lot more candid. They will ask questions. They will ask things that they might not have asked if it was going to be recorded. So I don't record our meetings here. These are for us. We can sit around. This got so big that I had to change it to a stage. And the reason I went to a stage is because we couldn't present. Once we got over about 40 people in here, it stopped working in one of the normal chat channels, right? So we just did it as a stage, and then you guys could see and hear and stuff. And then what I did was I recorded everything the Sunday after. So there's actually, in our Discord, there's a beginner start here section, and there's a playlist for the Linux sysadmin course. So that's on the top right of your screen right now. You guys should be able to see that. But there's a playlist, and I have all 16 weeks up there as I recorded them in a stream like this. So those are up on YouTube for people that want them. They're going to stay up on YouTube, and I will reference back to them even during this. So let's say you miss a couple of weeks or something. We still will be meeting for you guys that want to meet. We'll still meet on Discord. It's 39 people now, but we had 208 at one time last time we ran it until the thing crashed. Because, again, Discord like wiped it. It was really annoying because it was in late October because I was in Hawaii when it happened. It was super fucking annoying. They wiped it and nobody was interested anymore. Super annoying. So anyways, there's that. YouTube, you said, last run I did the admin course till Unit 6, then life happened. That's fine. Hey, you could go back and catch up. We're going to do it again. It's obviously free, right? We don't charge anybody anything for it. But you guys are welcome to come and hang out. And look, I tell you guys, like, whether or not you finish it, whether or not you actually get one of those cool little certificates for it, that's not as important to me as learning something. If I went through it, like if I wanted the cert and that'd be cool, but then, you know, I missed the boat, I would still go through for myself and go touch all the pieces and make sure I understand them, because I think I really do think that that's valuable to you guys. Like, I think for me, like if I was trying to get into the systems world for the first time right now, I would go soak up as much of that stuff as I could, right? So that's kind of my thoughts. Yeah, YouTube, I think you can do the course. And then, yeah, I think we're going to run the security course at the same time as the Linux sysadmin course. Obviously not the exact same time because I can only be in one place at a time. But I will probably be running them concurrently. And then it's just going to be, I mean, at that point, it's going to be the amount of workload most people want. It's guys, I make this a lot of work not because I'm not trying to like crush anybody's spirits or anything. I want you guys to see that like you can learn this, but it does take work. It's not just something that sticks in your head easily. We got to spend time with it, right? Part of the reason I teach, it's part of the reason I do this stuff, is I get to think through things that I might not always do at work. So there's something to think about. Yeah, Hayes, how is the new job? I don't know if you mind doing a little write-up down in Discord or anything, but that's awesome, man. Or man or woman. I never know what anybody is online, so I apologize. But hopefully you're enjoying it. Look, systems work. can be frustrating. Like all of us get frustrated. You just got to have your outlets, right? You got to have your places to go spend time and places to, I guess, understand and practice. So, yeah. Man, fair enough. I actually, it's funny. It's YouTube tells me the numbers. YouTube like tells me the breakdown of people, and I have like 99.5%. It might even be like 99.8% males that watch me. And I told the wife, I was like, well, that tracks. That tends to track, I guess. So, let's see, what are these other ones? But yeah, there's a lot of stuff to go study and work on and get better at. You guys are always welcome to come down there and do that stuff. For people that are watching, I do have the Discord up, so if you have questions that you want to ask on Discord, you can. You can also do an exclamation mark ask, and the bot will respond to you. And the bot will be much less polite than I am, I think. Yeah, it can be. That's right. It's a sausage fest. That's fair. I remember my boss. I was at a college, so I work for a company called Redline. You guys know that, and Redline basically hires me out as a contractor. Well, I'm a contractor, but I get embedded with teams sometimes. And I was working for a big college in the Northwest in the last year, and my job with them was to build back their HPC team. They had a team that had been decimated down to only 2 people, and they like desperately needed just hands on the system. And I came back, and Enzo Bear, they're in the northwestern area, sure. Yeah. When I say sorry. So, yeah. So sorry. So I said Northwest. Sorry, I should have said Midwest. But it's actually funny though. But anyways, so they I should have said Midwest is where that college is. But anyways, they had lost 50 years worth of all their HPC environment, like because 4 different admins left within about 6-month period. So they were down to the last 2, and one of them was my manager. And she was really good. She was technical. She had been on the team. She was a scientist. So this team, a lot of colleges will have researchers and stuff, and she did all that. But she told me when she went to supercomputing a couple of years back, she looked around the room, and in a room of 200 people, she was the only woman in the room. And I was like, wow. I mean, that is supercomputing and high-performance compute, though. I mean, that's kind of the spread. As we were mentioning earlier, 99.8% of people that watch me are male. That's just an interesting thing. And I would never know that except YouTube tells me all that, right? So, YouTube, you said you started a new job at an MSP a couple months back. It's Microsoft, but you want to start in Linux in a year or 2. Yeah. Well, YouTube, I'll tell you, just if you keep plugging away, that's the best chance you got at getting over into Linux, you know? Keep plugging away, keep doing good where you're at, and, you know, we're all hobbyists around here, but then some of us take it and decide to be pro, you know? Enzo Bear, you know what's funny about that is I actually got told that I sound like I'm South African. They were like, somebody asked me a while back, they're like, are you from South Africa? You've got this. And I said, I have never in my life heard that I had an accent of any type. You know, I'm from like the Southwest U.S., you know, Arizona. And then I spent some time in Colorado. And I don't think I have a twang of anything in my voice. So that's kind of funny. Yeah. Yeah, and I don't care. I mean, I don't care what people... Yeah, I'm the same way at Hayes. People are people. The people that want to be in this space are going to be infinitely better at this than people that are forced into this space. I'm convinced of that. Because, like, if you just do... You know, if you're doing Linux because you like it, and then you happen to one day wake up and you're working in it, you're just going to be like, oh, yeah, here I am. I'm doing something I love, you know. So, yeah, I'm from the Midwest. Because I know I don't have a lot of the twang or any of the... You know, I don't take my ka to the pak. And I don't any of that stuff, you know. There's an old my favorite version. I've watched a lot in my life since I was a kid of different Spider-Man cartoons, and there was one that they did a few years back, probably early 2000s, called Ultimate Spider-Man, and it was after the Marvel Adventures came out. But they did this Ultimate Spider-Man, and Spider-Man kind of has this little team of people, and they're working for Shield, right? Anyways, in this one, he gets pissed off at how people treat him in New York, so he moves to Boston, and the people of Boston love him. They're like, here's the key to our city, and they're like, let's all hear it for Spider-Man, and he's like, that's Spider-Man, and the guy's like, that's what I said, Spider-Man. And it's just so funny that he ends up leaving there because he can't. He's like, all right, I need to go back to New York, but it's just kind of funny. Like people were like throwing trash on him and stuff and hating on him, and J. Jonah Jameson's always giving him a hard time, so it's kind of funny. But yeah, Ultimate Spider-Man was also, they've got one of those episodes that's really funny with, what's his name, Deadpool's in it, and it's pretty funny. Yeah, Spider-Man. He can't say Spider-Man. He's trying to give him the key to the city, and he keeps saying Spider-Man to try to correct this guy. That's kind of funny. All right. So, I'm losing the thread. Where am I at here? I don't really have a plan for today. I just kind of wanted to hop on because I hadn't been on for a while. And what we can do, we're keeping an eye on the werewolf logs, making sure that the environment is running clean. There's a lot. We were talking about all the stuff that you can kind of glean from watching logs. We also have... Oh, Enzo Bear, you want to hear some networking, do you? You know, guys, I did a whole big thing on networking the other day, but I could talk some more networking, I guess, if people want. I can definitely do more networking. Let's all right, give me a second. I gotta retool everything over here. Let me pull up. I gotta go find a presentation on networking. I have a few different ones that deal with networking. Let me go look at my... See, I did an actual networking deep dive the other day. Or, something. Hold on. Networking. All right, we'll do the networking. We'll do it as a networking primer. All right, let me get this crap out of the way here. Also, let me go check if Pretzel Rocks is acting right. Pretzel Rocks took forever to load earlier. Hold on, let me stop my music here. Pretzel Rocks is how I normally play music around here. We will do spooky music. That sounds spooky. You guys hear that? Alright, I won't play it that loud. We'll go like right there. Put the sound up. Nah, I won't go that loud. Hold on, let me move it back down here. I like it to barely move on the screen, so it's not too loud. Alright. Right there. Alright. So, let me put this up. You guys should put this back. All right, you guys asked for networking. Well, Enzo Bear asked for networking. And I made those things more expensive, so I'll talk about some networking. So, all right. You guys should be able to see me. This is a primer for networking. We went over this the other day, so this is recorded. I have a recording of this, but we'll talk through it. And then I guess, Enzo Bear, if you have questions or if anybody has any questions, we'll talk through some of the different pieces of it. I also have my stylus here because I'm going to have to draw in some places on this one. We talked about this the other day, but this is one of these things, like once you get it to stick, it'll always stick. But like when I show this stuff to people, especially around subnetting, they sometimes have a little bit of problems. I will say one other thing about this before I go into this. Subnetting has been going away. IPv4 subnetting has been going away for over 19 years now. I remember when I was in college, maybe even 20 years now. I remember in college they were like, "Oh, it's going away tomorrow," and well, here we are with IPv4 still kicking. So just IPv6 is coming, and one day you will never have to subnet again. But that is not this day. You are still going to have to do some of this stuff. So all right, so I'll pull this up. You guys can all see me. Looks like you guys can see me. Okay, good. All right. Oh, hold on, I gotta change this. If the music's going to talk to us, I got to change it. Although that's a pretty catchy little tune. All right, we'll leave that up. So here's my quotes to get you interested. These quotes come from XKCD. If you guys aren't familiar with XKCD, oh, hold on, I got to change this too. It was bugging me. All right, better. When you're in studio mode on OBS, it like flips and then it shows you both things, and I was seeing the other window and it was bugging me. So these are kind of my thoughts on it. There's this guy, Arthur C. Clarke, who had these kind of rules about technology, and one of the things he said about technology was any sufficiently advanced technology is indistinguishable from magic. So what that means is, and this is something I tell my college students a lot, they'll be like, well, how does that work? And I'm like, oh, just for now it's auto magic, right? It's auto-magically happening. Don't worry about it. But then once I explain it to them later, or when we get to that and it becomes germane to the point that we're trying to make, that's when we start to kind of dig into that thing. And then once you see it all peeled back and taken apart, it's not magic anymore, right? So for like a lot of people, how DHCP works is magical, and how, the boot P protocol works, and all these different things that exist, they're all magic until somebody shows them to you. So the goal of this is to kind of at least take away some of the magic pieces, right? And then there's one other thing I'm going to pull up about this, because this is something that's in our actual Discord here. And I've been putting stuff in here. I've been going slow because nobody's really been participating too much. But I asked a while back, do you guys want me to take... There's this iBook. There's a IBM Red Book. Red Books are these free publications from IBM. And there's this free IBM Red Book right here. And people have asked me in Discord before, hey, what do I need to know? Like, what's the bare minimum I need to know for being like a Linux engineer or Linux sysadmin? And my thoughts on it are, coming from a guy who did networking before I got into Linux, before I got into Unix or Linux, the bare minimum, I think, is kind of encapsulated in this book. So I always tell people, if you've got the time, read, the first 170 pages of this book, basically. And you might say, really, all of that? It's actually a really good book. I'll link it to you guys. I think this is a fantastic book for... I think it's a fantastic book for, like, somebody who has no knowledge of... Like, you've just existed in a world that has networking, and networking is magic to you. This will demystify probably 85% of it that you need to know for running like a local network or those kind of things, up through page 170. Then you say, Scott, why don't you want them to go past 170? Because while this stuff is really good, the difference between a distance vector and a link state router and the things that are happening there don't matter to a systems engineer. It doesn't matter to me anymore. There was a time when that was all that mattered, but right now, this doesn't matter to me at almost anything I do. The difference between distance vector and link state. I can still tell you all about them, but the point is, like, this stuff becomes out in the stuff that's going to stay magical unless you decide to be a network engineer, if that makes sense. So the link is there for you guys that want it. I think it's dated. The book is from like the early 2000s, but guess what? The networking we use is from the late 70s, so it's still like, the same thing. All right, anyways, what I started to do, though, was I have these little discussion posts where you can go. This one was from earlier this month, and it's like, read pages 20 to 27 of this book, go look these topics up. What do you understand about them? What don't you understand about them? And then people could put some information in there. And then I did this one, which was 2933. There's actually the next section that I was going to do. There's 4 different topics about this. But anyways, so the point is, if people are interested in that, I'll keep doing that in the Discord. But it's just, I already, like, I feel like a jerk saying it, but I already know this stuff, right? Like, I don't need to do that stuff. Like, I don't need people to validate me. I already have college students that have to listen to me, so I don't need anybody else to listen to me. Like, you guys are choosing to listen to me. I have college students that have to listen to me, right? There's a difference. So anyways, Vint Cerf laid out TCP on a cocktail napkin. Yeah, it's the protocols, yeah, and I don't even know all the history besides that. I just know when, DARPA started publishing things, right? So, Yeah. When handling network, can you? Yeah, YouTube, real quick. I'm gonna show something because, and the reason I'm gonna pull this up is because this is not in this talk. So I am gonna pull up one thing real quick. Hold on. I think it's in my internet security topics. Hold on. It's got my name on it. Hold on. Yeah. Let me, guys, I'm going to jump to this for 1 second. We're still on networking, all right? Don't anybody think I've left networking. I'm still on networking. But let me show this one thing real quick. The theme of this one, when I originally wrote this for our group, our professional Linux users group, and then I showed it to my college students later. But the theme was the internet's a scary place. Like there's a lot of stuff going on, right? And we got down to here. So I just got asked a question about, can I explain a reverse proxy, right? This is the crux of how a proxy and a reverse proxy works. Don't go reading up on token ring. Yeah, don't go back that far to token ring. Proxy always means on behalf of. That's what the word means. So like a proxy would be like, well, I don't want to go deal with one of you, so I send somebody to talk to you for me. And then hopefully you don't kill that messenger, and then you send the messenger back to me, and I'm like, okay, my proxy or my messenger has arrived, right? Well, most of you probably think of proxy servers like you hear like these VPN tunnels, and then you can go and act like you're in Europe, so you can watch something on Netflix that you couldn't watch, because there's all I don't even know any of that. I don't do any of that. But a proxy works forward. It's a forward. This is technically a forward proxy right here, right? But what a reverse proxy does is it acts as an intermediary between the clients and the servers so that I don't have to ever let you into my environment. You never know what's going on back here in my environment. You just don't know. You get stopped at the door, and then the reverse proxy takes your request the rest of the way. This is super valuable for web application firewalls, TLS termination, and offloading of processing associated with TLS termination. It's exceedingly important for guys like me that want to, I've got to update and work on these servers back here, and I've got to work and like DevOps teams that are even like slightly above me, kind of like I'm the guy doing platform stuff, and then the DevOps teams, maybe I need to patch these servers and roll through, or the DevOps team needs to update from the version 1 to the version 2 of something, right? Well, all of these things a reverse proxy makes better. Most of you probably have learned about reverse proxies from the term load balancer. A load balancer is literally just a reverse proxy. That's all it's doing, is it's taking requests and feeding them to different backends, right? And then if we're talking like AWS load balancers, we can split the types of reverse proxies and load balancers we're dealing with. We can deal with all of the backend endpoints. Then this can also check health of endpoints. It can do what's called like system drain. Wow, that was loud. It can do what's called like system draining. That was super loud. Jeez. I don't have that thing up very loud either, so I'm surprised it could go that loud. Anyways. That song's good. Okay. Anyways, I don't know if you guys heard that. That like hit really hard, that sound. All right, so reverse proxy is doing that. So then you say, well, how does that look in practice? Well, the way these grew up was the networking. The networking was being split right here, and this thing was acting as like a SOCKS 5 proxy or something, right? Or SOCKS, it was SOCKS 4 and then SOCKS 5, and then a lot of people now use this this thing called a squid. A squid is a type of proxy, right? That's super easy to understand. Yeah. So this is kind of how it grew up, right? Reverse proxies look like this originally, right? You would come in, so this is you, one of you, and you're coming to like my Scott server back here, or my set of Scott servers. And if the original problem was, well, anything that comes in will just get forwarded anywhere. Well, that's a problem. Well, no, hold on. If I was serving static content, this is fine. So if I was serving like a static web page, and you were going to like a flat static like markdown web page of just I don't know, something that I uploaded this morning, and it wasn't changing anything, and there was nothing to log into or anything, this is great. Because it didn't matter when your request came in if you went to this server, and then you said, okay, well, I want to refresh it, and then you went to this server. That doesn't matter, right? Like if you're looking at static HTML, who cares? Who cares? But the web does not run on static HTML. Static HTML exists out there, but it's not the way that things run. So what we had to do was we started to do like session stickiness, because what would happen here is you would come in here and you would be throwing like some some Reeboks or some Nike shoes into like a cart, right? And this system would know about your transaction. And then let's say your next session went down here and he doesn't know about your transaction. And you're like, that's stupid. This is this is like a waste of time. Like, I'm not putting that shit back in my shopping cart, and you'd leave. You wouldn't stand for that. So this does not solve the problem of going to a session that understands the thing. So now what we did was we turned on session stickiness, and this is kind of like the progression of levels. Hold on, I'm missing stuff. Did you use reverse proxies to implement gateway servers? I remember. Yeah, I use. You can do load balancing without a reverse proxy. I should mention this as well. You can do load balancing inside of DNS queries as well. And then at that point, you don't really have a reverse proxy system sitting there. So I guess in that way, I now do have to differentiate. You can do reverse proxying with sorry, you can't do reverse processing with it, proxying with it, but you can do load balancing inside of DNS, which is simply just looking at different queries. So your DNS can do static and round robin and all these other things as well. But let's just go here and say with session stickiness, we solved this problem. So now every time one of you come in, you go to the same web server because of the session cookie, and the load balancer can understand and always send you over there. And we have now solved the problem of you putting your Reeboks or your Nikes in a cart and buying something from me. But as with all things, as with all engineering solutions, a new problem emerged right here. Does anybody know what the problem is right here? Can anybody tell me the problem before I go on? I was just a lowly dev back then. Yeah. All right. So what's the problem? So here's the thing, right? I said that right here, you're a client and you don't know what's going on and you don't have any control over this. Well, what's the problem if I set a session cookie? Well, stealing cookies is always a problem, right? Or saying you can have all their cookies and then I got fat. Yeah. So I've always joked around. I'm going to go real far down the rabbit hole for some people. Has anybody here ever finished all the episodes of Naruto? Not Boruto. I never went into Boruto, but Naruto and then Naruto Shippuden. It's like 700 and something episodes. I've done it. And there's this little character, there's these two little frogs that he can summon. And at first, they're about as big as my hands. And then the second time he sees them, like later on in the show, they're about as big as this room I'm sitting in. They're huge. And he goes, yeah, you probably don't... And the frog's got this really high voice. And he's like, yeah, you probably don't recognize us because we got fat on account of all the snacks we ate. So I always tell my wife that. I'm like, yeah, well, this is on account of all the food you made or whatever, whatever I'm joking around about. But that stupid little toad, I think his name is like Yama something. One of you guys could probably look him up. But this stupid little toad, he's so funny. Or frogs or toads, I don't know what they are. But yeah, Naruto can summon them. Anyways, but he's like, yeah, you don't recognize us because we got fat on account of all the snacks we ate. And he's got this really like nasally voice. But anyways, where I'm going here is, what's the problem with a session cookie like this? It is this. It is that now you are tied to this. Remember I told you guys earlier when we were on this one, I can go work on these? Well, hold on. What if this session cookie, what if one of you goes and puts stuff in your shopping cart and then you just leave it there? So now, if I wipe this server, I wipe the memory of whatever you were doing, and then now we're back to this problem of you losing your shopping cart. There's no persistence there anymore. And also, if users are tied to a session, right? Like if a user coming through is tied to this session back to my web server, I have to stop the load balancer from establishing new connections over here and doing what's called draining the connections out, right? That is a nuisance. That is annoying. But since we like to do work as, Linux and systems engineers at night, we're okay with it. We're like, we'll drain that one and watch some Netflix, and then when this one's completely drained, we'll do our work on it, or we'll have Ansible can do this. You can tell it to drain, tell your F5 to drain the load, and then when it hits an acceptable amount, you can cut it over and that kind of stuff, right? But there's a problem here now that, the session cookies tie users to things. So you got 5,000 users here, 5,000 users here. You're not getting to those servers anytime soon unless you have more servers, and then you drain a certain percentage of them. It causes kind of a bit of a problem. It causes a new problem, but it solved this problem. So then we come down, and this is the way it used to work, was like a user came in, and they had a session, but again, you're tied to that system. And then user 2 comes in and goes over here, and they're tied to that system, right? So this is kind of the way that like a load balancer or, again, a reverse proxy system works. But the way we solved it all, and the way that like AWS will tell you to architect it, and you guys go and get your solutions architect associate, or if you spend a lot of time in the DevOps world, this is the solution right here. This one. This is the actual way that we build these now. So you've got a load balancer here, and you've got your front end stateless web. So a server can come in and it can ask whatever it wants of some stateless front end system that is showing the static content, right? And then that is coming to a back end stateless middle tier compute, and this thing is answering any buttons that you're clicking or forms that you're filling out and stuff like that, right? So because of this, you could be coming to any of these and you don't know. And if one connection comes over here and one connection comes over here, I don't really care. We can still use sessions and cookies and other stuff like that, but we don't really care anymore. Then our requests are coming back here to a stateless mid-tier. And this thing also, I don't really care how I get there. Doesn't matter. Because of this, anything that comes here gets written to a cache over here, right? And there's a cache that's recording what's going on. And then as the stateless mid-tier is doing its compute, it is writing I showed it here, but it's really coming here. All your requests are going down into like an SQS queue, right? That's SQS. But it's SQSQ, right, inside of Linux or AWS. So your requests are coming over here and they're waiting, and then these guys are grabbing them as they need. And then there's two things that are happening. Things are getting cached in real time, and then as they're completed, they're going to storage for backend database stuff. And this is the way that the modern stateless application works. Yeah, SQS is the Amazon Simple Queue service, yep. So this is the way that a lot of this stuff works. You've got a front-end load balancer. It's going to any number of endpoints. As long as I can handle the number of connections at any time, I can take this down and upgrade it to the new version of my front-end app, like my web stuff. I can do it here. Any of this stuff can go down, and you're none the wiser. Any of this, as long as the computation that was happening in it has happened, and it has responded back to the queue or written off whatever, these can also go down at any given time. I can just X them out. Because there's caching and things are being queued and responded to, and then only things that we validated and approved and because of our PCI connections and those kind of things, we're doing payment card information, only things that are actually completed as transactions get written into backend storage. And this is the kind of the goal of the modern stateless application. But the reason I jumped over this from networking was the question was, what is a load balancer, or what is a reverse proxy? And it's just a load balancer. And this is how we use it in the industry. And this is basically the way that they do it inside of pretty much everything. All right. So back to networking, right? Here's the topics for this talk. Here's the topics for this talk. I'm going to talk about, and by the way, some of you guys might go, well, didn't you just do this like a week ago or a week and a half ago? Yeah, but I got asked to do it again, so I'm doing it again. We'll get through as much as we can. But there's a simple communication model. This is something that I picked up early on in my engineering career. I started out as a network engineer, and my bachelor's degree is in network communication management, so that's kind of my, that's what I teach. That's my background. But that being said, I really think all engineering kind of follows these same archetypes as you look at stuff. So simple communication model is probably the most apt one to use for all of networking and all of the ways that we communicate between systems, the way I communicate to you guys, the way you communicate to other people, the way that you communicate information into your car while you're driving it, the way that your tablet talks to you when you're watching something on Netflix. Communication always happens the same way. And all the networking that we're going to do, if there's ever a spot where you're like, okay, stop right there, how does this model apply? You should be able to apply this model to literally every piece you look at, and it should make sense what part of the model you're in. Does that, hopefully when we get to the simple communication model, you go, well, that's really simple. And I go, well, that's exactly the point. All right, and then we'll do a networking overview. We'll talk about the 3 types of address. There's a 4th one if we care, but mostly 3 types of addresses at the networking layer. The 4th one matters a lot more to the application people, but it does exist. And then we'll talk about subnetting, which I think is, I have a buddy who, he's a director at a company, and he's the director of audit, so he does all that stuff. And he was telling me the other day, he's like, Scott, every time I get to subnetting, my mind floats off and stuff. And I said, I said, I've been teaching it a long time. I'm pretty sure you'd get it if you came and gave me 15 minutes for me to write it up. I'm pretty sure you'll get it. So I'll make that same deal with you guys. If you sit around and hang out for a little bit, when we get to the networking portion, I'm pretty sure I can demystify it for you. If you want to practice it and get good at it and make it stick, that's going to be up to you. But I definitely think that when I'm done with you, you'll be like, okay, well, I understand what the 1s and 0s are now at least. And if some of you guys were around a week ago when I did this, it's going to be basically the same thing. So, SSL offloading is huge, Kevin. Yeah, because guys, you got to understand, SSL is an asynchronous. SSL, which is now TLS, right? TLS offloading is a highly compute intensive, so you don't want your servers that are functioning as like web and app servers to be doing their own TLS on them. You want to see if you can terminate that earlier, so that then the traffic is trusted basically back. Anyways, we don't get into that in this talk, but that's definitely a truth of systems, is that I said asynchronous, but all asymmetric keying takes 10 times the processing, or 1 order of magnitude more processing than symmetric keying does. So something to think about. Are we going to have a network section of the security course? Yeah. Actually, networking will be a big part of the security. In fact, hold on, I'll pull this back up. Is this it right here? Yeah. So this is the security course for all intents and purposes. This is what I just put into our little prep there. So there will be networking in here. There will be networking in Unit 2. There will be some networking in Unit 3. We'll probably use some Vault for fun. There will be networking in 4. Not really networking in 5. Not really networking too much in 6, although you can be looking at monitoring networking. Definitely networking in 9. So yeah, I'd say half of it's going to be, it's not directly focused on networking. It's just to do the things that we need to. Networking will be involved. Yeah. That'll be a fun thing. So this is my tentative 10-week schedule right here. This is the one that I just sent over to. So the guys on Saturday, for people that are interested, the people that are working on Saturday over here, guys, in this writer's room, there's a few of them. I think more people have been showing up, but there's 7 that say they're interested. Those guys have been working on the Linux sysadmin book, but then they also wanted to get started on the security one, so that we can maybe release the security one even before, like as the course is coming out, we'll have that out there as well. Killa, thanks for enjoy not having to watch ads, because I don't know if any of you guys know, right? Because people will complain about ads sometimes. Here's the problem with ads on Twitch. If you say, well, Scott, can't you just turn ads off? Don't let them run during the stream. You can't, actually. That's part of their agreement. But hold on. But when do the ads run? Who here knows? When do the ads run if I don't run ads? Does anybody know? They run at the beginning. They're called pre-roll ads. And if you guys don't know, pre-roll ads are the #1 thing that'll keep people from coming in the stream. No, it's pre-rolls. And pre-rolls, you will sit there for 3 minutes before you come see some new guy that you've never heard of. So if you were like looking around and you were like, oh, I'm going to go hang out with that Het Tanis guy, and like, oh, maybe he's cool, and then you get hit with 3 minutes of ads, you're going to go somewhere else. So most of it, and in case anybody's wondering, the reason most people run ads on their schedule is, I don't get ads either, Killa. Yeah, I'm one of those guys. I just sit around and just soak up on Turbo. So I tell people all the time, like, the best thing around is Turbo, because then I don't have to watch ads. But I hate ads. Like, I don't watch ads in anything if I can avoid it. All right, and then we'll go do the OSI model, which is the same thing as we did before. I have two things that I really have to add to this. One is in the data link layer. I got asked to add VLANs. I have not done that yet, guys. I've been super busy. And then two, I have whole college classes that I teach on just the physical layer, just signaling and antenna theory. I could add as much as it's already in this presentation down here in just the physical layer. I didn't do that originally because I wasn't sure how much people would care, but I do need to add to this signaling, because the way that we signal and what the implications of how signaling works affect kind of everything. Oh, I couldn't even I like that. I'm gonna hold on. Let's go put that somewhere. Let's go put it on off topic. Hetflix. I think that's funny. All right. Hetflix. I read that and I was like, he said net. No, he said Hetflix. That's really funny. All right. Not Netflix. Hetflix. Not Petflix. No, none of that. That'll get us kicked off of Twitch right there. All right, anyways, all right, let's get into this. So, the terminal course objectives. So when I first gave this, and I'm going to tell you guys this as well, when we're done with the session, you should understand the basic components of computer networking. Also, I kind of thought about going through this one again and just adding a bunch of stuff from like Network Plus. And the reason I would add Network Plus stuff is because then I could tell you, well, you'll be primed up to go study for your Net Plus if you wanted to. But understand how and why we subnet larger networks. Like, why everybody talks about subnetting, but why do we do it? And then understand the flow of data through the network. What is a protocol data unit or protocol data unit? I don't care how you say that word. At each layer of the OSI model, and why does that matter? And then understand the term modularity and how it applies to a model. Can be said really good use of tools like Wireshark, T-Shark, TCP dump, and Netcat to understand networking. Yeah, in fact, in this, I actually pull up networking with Wireshark quite a few times. So as we do this, I actually have demos for each of the different components. Hold on a second here. I actually have demos for a lot of this stuff in my environment. Like, what does it look like in my environment as we were doing Wireshark? So I would tell you, anybody that wants to go deeper than systems level engineering, if you say, Scott, systems is not the world for me, I'd love to be down on the network, I'd tell you, wonderful. There's a way to jump down into the network and understand it, and a big part of that starts with getting on a system and turning on Wireshark. Because Wireshark is just, first off, there's a million labs online. It's free. There's a million labs online that'll show you how to use it, right? So like I don't spend a lot of time with you guys like showing you how that stuff works. I think that's one of those things that you'll go work on. But I do show you how, as we get into this stuff, hold on, as we get into like these, the headers and these kind of things that we're going to talk about here, as we get into the headers and the payloads, I do map this back. This is an IPv4 packet, and for any system, you can come in here and look at the IPv4 packet, and this right here is the same thing as this right here, as defined by the RFC 791, right? And then this is why RFCs are so important, is because when you want to understand the technical implication of exactly how something worked, you go look at that thing, because that's the exact technical implementation. Killy, you're going to be building your first time network and messing with server. That's, hey, everybody's got to start somewhere, right? I don't know what the Kelly thing is there, but all right. And then what's out of scope is becoming an expert. This is a high-level survey of things that I think are important. I would also tell you guys to go read that red book that I linked earlier, because IBM did it better. They have really good information in there. Almost everything, like as I read, like I've only been through maybe like the first 100 and something pages of that book. I haven't been all the way down to 170. Just looking at the topics, though, those are all the things that I would tell you about if you were trying to get like a primer on systems. Like that's the stuff I tell my college students. That's the stuff that like all my curricula go towards. Like it's yeah. So anyway, so this is networking. I got asked to do this. If anybody's wondering, like, why is Scott back on networking? Wasn't he just doing that the other day? You're always going to do networking in the Linux world, so we're going to always kind of touch this stuff. And one other thing, is it really only 4? Oh, wow. It's still sunny out. the wife's gone until tomorrow. She flew up to Utah to go hang out with the grandbaby. He turned 4 yesterday, so the wife was up there. We had a virtual pizza party, so I had pizza here, and then he wanted a cheese pizza. He said he calls her Nana, and he said Grandma can, or he calls her Nana again, but he said, can I have a cheese pizza when you come up? And she's like, you can have whatever you want. So she got him a cheese pizza, and then I was eating pizza here, and we had like a little virtual pizza party. So, anyways, where I'm going with that is I can stay up late tonight because the wife's not around. She can't. It's like bachelor pad tonight, so this is what I'm doing. I have a grandson. Yep, he's 4. All right, so here's the simple communication model. This is the simplest model that exists for communication to occur. A simple communication model. And if I go right here and I were to number these things, this is 1, a sender, encodes a packet by some protocol to be transmitted across the medium, or is affected by noise until it reaches a receiver. Receiver tends to be number 2. So this is 1, 2. The message, a packet, this should be message. I should have said message, but it is a packet in our world. So this is 3, and then medium is 4, so that's 3. That's 4, and where you will never exist in any system without noise. Yeah. What happened? I need some advice. Okay, yeah, give me a second. I'll read about that. Also, I'm going to take a break here in a second because I have been talking for an hour and a half. So, Wireshark's great. Yep. I need some advice when you can't get around to answering. I'm buying a Dell PowerEdge, Cisco ISR, and a 3650 switch. What size rack should I get that will be good for expansion but not crazy overkill? So, you guys can't see it behind me, but behind me over here, I have a little half rack. It was actually given to me by one of the members of our group. Before, I mean, I've been running ProLUG for a long time, but this was a guy that I used to work with, and he's like, hey, I got a half rack at the house. You want it? So I would just make sure that you buy a standard size. So Killa, if you're going to buy one, I'm not telling you that you even have to, but if you're going to buy a server rack, make sure that it is the standard, I don't know, what are they, like 38.5 or 39, whatever width they are. And then just, I would buy a little half rack or something. Yeah, maybe they're 19 inches. Yeah, I think they're what did I say? I don't know. But yeah, they're whatever they are across. And then I'd only get like a half rack. You probably don't need that much. You can get them, man, you could get them on the internet. You can, I mean, shit, if I was just starting out, I'd just stack stuff on my desk, but that's just me. I mean, whatever they're, yeah, 4. He's 4 though. He all he wants to do is play with Marvel stuff. That's all that kid wants to do. Yeah, and then just deep enough for, yeah. So Killa, it's a standard size. The 19-inch rack is a standard size. Yeah, is that what it is? 20. What would I call it? I don't know. Whatever they are. That's a standard size. So you'll find it all over the place. Yeah. Although I would tell you, I don't know that you necessarily need all those, but yeah. Why did I call that a packet there? Because a packet is one specific. Anyways, it doesn't matter. Have you kids heard of the World Wide Web? Yeah, for sure. You know what's funny is I actually use this line sometimes on people on the internet. Like, so I've been on the internet since '93. Like I was a kid, but I remember getting in the library and getting on the internet back in '93, right? So I will jokingly sometimes tell people, like, I've been on there since '93, and now seeing this message, I can finally just sign off of here because I've finally seen the dumbest thing I'm ever going to see. You know, something like that. So, yeah, YouTube, I definitely have a grandson. Yep. YouTube on the YouTube side of things. All right. So, a simple communication model. And the point of this is the most simple thing that actually works to send data anywhere, right? There is a sixth one, and that is for effective communication. It's called the effective comm model. And I'm gonna leave that like that, and I'm gonna ask you guys. I'm gonna take a break real quick. If you had to guess, don't even guess. If you took your best educated understanding of systems in this world, and just think through all the ways that you think or know that communication happens. Oh, I was on AOL, yeah. Yeah. I was definitely on AOL. If I said that there was a sixth thing that caused this to be the effective communication model as opposed to the simple one, what do you guys think it would be? All right, I'm gonna put a little timer on. Hold on, hourglass. Put a little timer on. Here, where's my hourglass? Say break and think. Whoops, break and think about question. All right, and then I'll put for you guys, just because I'm sure everybody wants to know how Ranger's doing. Here's Ranger. Look at that dog. All right. We'll put it like that, so you guys can still see the model, but you can also see Ranger over there. All right. So you guys need to think about. Whoops. You guys need to think about what it is. Hold on, I gotta make it bigger for a second to turn that off. I'll collapse it back down. There's Ranger. Look at that. Look at that Ranger dog over there. All right, I'm gonna restart the timer. You guys have 8 minutes to think about it. What do you think you need to add to the simple communication model to make it an effective communication model in just one step? All right, I'll be right back. And noise is everywhere. That's true. Oh shoot, the wife wants to call me. Give me a second, guys. I might have to go walk and talk to the wife real quick too. All right, you guys think about that. I'll be back. talking to the wife. What did you guys have? What did you guys... What? I think that you guys got it, but I wonder if somebody cheated. Or maybe you already knew. Or that's actually true, though. Hold on. Feedback of any type can encompass what we call, so yeah, 6 feedback is feedback. And feedback can be error correction, EC, or any of those other things. We have a bunch of ways. Yeah, I was sitting around talking to the wife right now. Hold on, all right, let me put my camera back on. Camera back on. All right, let me move this up. Still take a break, you guys, because I know somebody might have walked away and thought they had another minute left. So we'll let the break finish up. But yeah, I was talking to her. She's up in Utah right now, hanging with the grandbaby, and she's coming back tomorrow. She was only up there for a few days because it was his birthday. So yeah, and all right, 6 is a feedback loop. Yeah. So a lot of times people will call that the effective communication model. So the simple communication model, 5 components. The effective communication model has a sixth piece to it. And one of the things that I've told my college students for years, I've told engineers that I've mentored for years, is this is the simplest model that is known to man, the simplest model that's known to any of us that are engineers, that works for sending data. These 5 components must be there. There's nothing simpler that's ever been found, nothing simpler that works. It's these 5 components must be there. So a sender encodes a packet, and then that's by the way a very important term. A protocol is the rules that govern how communication occurs. There's certain protocols that are happening. Oh, I'm talking ahead while we're still on break. We're still on break, guys. Take your break. You need error correct. Yeah. So anything. But by the way, as you guys said, like a feedback loop. Feedback allows for all of the other stuff, all of the error correction mechanisms to be there. All of those kind of things. Because by the way, somebody could rightly say, but Scott, couldn't you build it into the protocol to have error checking as you send stuff? True, you can. But where's the resend? Without the feedback, you never get the resend. So you do need a feedback loop for the last part of effective communication to occur. But communication can occur in one direction with everything but the 6th piece. So, all right, that's a simple communication model. That's going to govern everything that we did. That kind of stuff. If you meet a caveman, make a friendly gesture, and they clubbed in return. You need hair. That reminds me of anybody here ever seen there's an old show called The Twilight Zone. And look, I know everybody knows what The Twilight Zone is, right? There's even a modern song that's like something like The Twilight Zone, and somebody's always watching me. I know people know what The Twilight Zone is, but in the original show, The Twilight Zone, there was one of them where the guy was like he was one of those people in a box. He was a mime. And there was this creature that had been captured, and when people would go in, they had to like mime to talk to him or whatever. Johnny, not Sasaki. No, this is even before you get into UDP and TCP. This is communication in general. This is an ant talking to another ant via chemicals. This is a rocket talking back to Earth. This is literally any communication model that we know of. Is you need those 5 components, and this governs everything that you can do in the systems engineering world for communication, right? All right, so this is a simple communication model. This governs everything else that I'm going to talk about in this little primer. Again, we're on the primer because I got asked about it, so this is where we're at. It's our Friday. We're hanging out. I have more co-working to do later. I might jump back into co-working a little later, but I got asked to do this, so I hopped on here. By the way, I swear this music, it is spooky like it should be, but I swear it's getting louder than it's supposed to. So you guys let me know if the music gets too loud, all right? I know it should be kind of low for you guys, but all right. Here's a couple of fundamental pieces of terminology that you kind of just have to understand for all of this to make sense. You've got a sender and a receiver. You will typically, in the engineering world, see them. Actually, the standard is TX and RX. You will see that across all of your systems. So if I just come here and I go to just like a normal Linux system, and I just say IP adder, I may see some information here. Maybe I don't. If I do a SAR-N, like TCP, oops, TCP, and then just say like 1 every 1 second, I should see, I don't see it there, dev, right? Dev should do it, I think. Yeah, so here I see the sending and the receiving. So here's my receive packets and my transmit packets. My receive kilobits, those are bits because they're capital B, and transmit kilobits. And if anything was happening on these systems, I would see it right here, right? But just so you know, nobody's gonna, in the future, you know, as you go further and further into doing systems and engineering, you're not gonna have it explicitly spelled out to you that this is receive and transmit. So you do need to know that. In the again, on the networking side of things, less on the system side, you need to know what a DCE and a DTE are, and they're the data circuit equipment and data terminal equipment. And DCE tends to be where the vendor or ISP comes in, and the DTE tends to be your side of the communication. There is a point in all autonomous systems. Autonomous systems are the idea that like I control all of this, or my team controls all this, and you guys control all that. And where our interface occurs, there's a point of demarcation. Demarcation always means where your responsibility ends and my responsibility picks up. And we may troubleshoot between them, and we may argue over where the demarcation is. But typically for me, especially in the systems world, if you say, Scott, what's the demarcation between your responsibility and like some other team? And I will 100% of the time always say this, and I will die on this hill. If I don't have admin rights to it, I am not in charge of it. And I think I told you guys this, like there was years ago, I used to, I was the platform engineering lead for AAA, which is CSAA for people outside of it. But AAA is like the big car club in the U.S., and then they have an insurance side. So anyways, I was the platform engineering lead, had about 5,000 systems between Linux and Windows. And the thing about that was, I remember our ServiceNow team came down. ServiceNow controls their CMDB, which is Configuration Management Database. And they were like, okay, and we were on a call all the way up to like executives hashing this out at one point, like my team fighting with their team, because they said, you are responsible for updating how your systems are in our CMDB. And I said, that's fine. Give me admin access over it. I'll hit it with an API. I'll update my stuff. You guys will never have this problem again. And they came back in front of everybody on calls and said, we will not give you admin access over that in our system. And I said, well, then don't tell me I'm in charge of it. Right? Like I'm in my house right now. I have these aren't keys to my house, but these are keys to something in my house, presumably somewhere. And if you tell me, Scott, you're in charge of that thing, and I say, okay, give me the keys, then I will be in charge of it. And then you refuse to give me the keys, I'm going to tell you I'm not in charge of it. And you say, well, when you say die on a hill, I mean, I'll say let me go before, like, fire me. I will not take responsibility. And I would tell, this went all the way up to execs. And I just said, and I would say over and over again, if I'm not in charge of it, I'm not in charge of it. And they'd say, no, you are in charge of it. And I'd say, I don't even have permissions to update it. How can you say I'm in charge of it? And then, you know, this would go back and forth. Because here's the thing, I'm not going to, like that's the opposite. Like that doesn't make sense from an engineering standpoint, right? Like if I'm in charge of the thing, I'm just going to use an API call, update the shit, and it's never going to be wrong again. By the way, they never gave me access, so that stuff probably is broken to this day. Because it has to be manually updated because they can't get the information. Anyways, point is, autonomous system is system under my control. Autonomous system is system under your control, and then where they communicate and talk is your demarcation point. And then to even deconflict things more, in the systems world we have many metrics. We may have the metrics of speed, link. Speed tends to be like bandwidth, or we could have aggregate throughput. We can have what other metrics might we have on systems? There's metrics of reliability on links, like how often a link is up or down. There's all kinds of things. But the point is, if you're telling me that a route is good because of the fact that it is the fastest link over there, but my protocol that wants to talk to you is only using a thing called distance vector, which we talked about earlier a little bit, and I said didn't matter, but it will matter for this 1 second. And I'm only talking in hop count, and you're talking in the cost of the link, which is like the weight of the speed of it, then we're talking two different things, and we're never going to come to terms. So in an engineering sense, you need to understand your metrics, so you're talking about the same things when you're figuring out, how a system works, right? Okay. All right. Anyways, yeah, Enzo Bear, that was a bad one. I told them, I was like, you can fire me. I'm not taking responsibility for that system. Neither is my team, and we never did. So, if that's what you were saying, damn about, which I imagine you were. So, all right. So here's the three main types of addresses you're going to run into. There's a fourth one again. It's the port number, but typically you're going to have something like a DNS address, and then a DNS address would be like, from my jump box, can I get the host for Google? This is a name that's easy for me to remember. These numbers are not easy for me to remember. So this is a mapping between what we call like a human readable address and an IP address. Then we got IP addressing. That is a hierarchical form of addressing that comes up in, got it, good, that we apply. You have things that are non-routable that can only be used internally. You have gateways of last resort, and you have ways that we cause data to flow in and out of networks, right? That's what IP addressing is. And then at a high level, MAC addressing, layer 2, is hardware layer addressing that is burned into the hardware. It is not always burned in such a way that it can't be changed, but it tends to be burned onto physical devices in such a way that we could say, this Lab 5 box exists here, but there's no logical hierarchy to this. Meaning, Lab 5's hardware address right here is like my name. My name is Scott, whether I'm in this room of my house or whether I'm in the other room, whether I'm downstairs by Ranger. No matter where I am, my name stays the same. Where's Ranger? Ranger's not on his bed. What's that dog doing? Anyways, if I was down by Ranger, my name would still be Scott. This doesn't change depending on where we are. Your IP address does, because it is where you logically sit in a network. Yeah. So MAC randomization inside of virtualization, where things just come up. In fact, I was talking about this earlier, see how all these are different? If the first 6 hexadecimal characters are different, you are, just across the board, you are almost for sure in a virtualized environment of some type. Because these only have to be what we call locally unique. They have to be locally unique, meaning if I was Scott, there could be no other Scotts in the room. In that sense. In the sense of these have to be locally unique. They do not have to be globally unique, but they have to be locally unique, which is funny because a frame never leaves the source address of a frame never leaves the network it's on anyways, so it doesn't, because all frames get stripped off and then passed on the other side unless you're doing something with hardware. All right. So anyways, this is an important thing to understand, these 3 at a very high level. In your system, you can tell a lot about what's going on by these addresses. Like if I wanted to know at a high level if this werewolf server was working, maybe there's some kind of problem here, I may just say host www.google.com. And I very quickly now know that all the way up through layer 7 DNS address resolution, my communication has allowed this to resolve. If I do 192, here we'll ping www.google.com, and I'm getting through all the way over there. Now, if I happen to ping that, and it still comes back with this, right? It still resolves, but then I can't ping to it. I get some kind of timeout. Well, that starts to make me think about other things. Like, is there something else in between here? Does this part hang where I don't get a name resolution back, and then I got to start looking internally? Inside your systems, you always have a route. This routing table will tell you how your system is going to send things, and does it have a default way to send things if it doesn't know what to do. This might seem kind of strange to some of you, but in the systems world, even in modern Linux systems, sometimes you do not get a default route, and you have to go set it. And devices will talk internal to the network, but they can't leave the network. So this is the thing to look for, is there a default route? Logically, can I get to something that's not in my internal network here? because this. Oh, you have host not found. So if host is not found and you're on a box that's Red Hat based, you can say DNF what provides host, and it'll tell you what provides that command. Routers do not even have to have their own default gateway, and Zobair no. A router has what's called a default gateway, or in their vernacular, it's a gateway of last resort. If you don't program a gateway of last resort into a Cisco router, routing is a lot like hot potato. A device gets a packet and it goes hot potato as it looks through its routing table. And if it doesn't have a gateway of last resort set, it goes like this, just drops it on the floor because it's too hot to touch. In my system, it's bind utils. Yep, Linux developer. There you go. apt has a package thing that'll find it too. I got to look in my notes over here. But apt has a way to find that as well, but I don't know apt as well as I know like DNF and Yum and those kind of things. Yeah, but Enzobear, a router does not assign a default gateway to a system, no. Your system has to have its own, or it's going to, the routing function in your kernel is going to drop it right here. So, yeah, on my side, it's bind utils. You also have NSLOOKUP for, I love NSLOOKUP, I think it's great. And you also have dig. So dig, NSLOOKUP host, just ping it. Ping has to resolve a name or it won't be able to ping, so that's another thing. But there's all these kind of things. Now, let's say I couldn't get there. I don't get a name resolution and then I don't get the ping over there. I may come here and say, well, my next hop is, can I ping 192.168.200.1? Can I get to my gateway? Hold on a second, I gotta see who this is. Hold on. This is Scott. Nope. They don't want to talk to me very much. If they put me in a waiting room when they call me, I don't think they want to talk to me very much. What is this? Google Play? Oh. It's actually funny. I just got my Google Play for my Discord Nitro. So I think that's like $10 a month or something too. All right. So here's some things that I can see, and I can see this is actually interesting. You can do the same thing here. IP-BR-ADDR will show you a brief. And I had forgotten that this one had these weird ENXO interfaces. What kind of... So my Rocky Linux 9.4 is Blue Onyx, right? And then that's the version that I have, and then apparently it uses ENXO capabilities like that. I think that's a weird, that's not a standard interface, ENXO like that. Typically we'll say ENO or EN0 or ETH0. ETH0 is a very common one. Yeah. Okay, so again, you can go and you can look at your systems and you can see all of these. ARP is a great way for determining how MAC addresses or hardware addresses map to your IP addresses. So ARP is a great protocol for that. You'll see a lot of ARP traffic in a normal network. This is just a normal network running right here. And we could go and just look for the ARP protocol, right? We could just track apply as a filter the selected, and we would only see if the protocol is equal to ARP. And then now all it would be is who has this and tell this. That's all it is. And it's broadcasts. And you say, well, how is it broadcast? Well, it's actually broadcast at the destination right here says broadcast in the MAC address. And the MAC address broadcast. Does anybody know what the MAC address broadcast is before I tell you? Right? MAC is 48 bits long and it's hexadecimal. But if I wanted to make it a broadcasts are almost always just all ones. It's a bunch of Fs. Yeah, it's a bunch of Fs. And could you go look at that? Right there. Bunch of Fs right there. So I tell you guys this stuff, like learning your tools and using your tools, you learn things or you hear about things, and you know, if you just hear me and maybe even look up there, you might retain some of this stuff. But if you go play with it and you actually run this stuff and get better with your tools, The thing I always tell you guys is you don't want to learn how to use your tools like tomorrow night, Saturday night, you get called at 2 a.m. and you're like rubbing sleep out of your eyes and somebody's asking you something about the systems you're in. You don't want to be figuring out your tools then. You want to know them before that. Yeah, it's all F's. But that was an actual capture of that, so we could validate that was the truth, right? That's what we know. So, all right. So this is my section where I get to the quick binary rundown. This is where I tell you guys that I think that anybody can do this, and I don't think that there's anything here that you can't do. But I'm going to do the same thing for people that missed the primer last week. I always go with the first thing I hear, too, so get your typing ready. Do you guys want me to start all the way back at the beginning, or do you guys understand enough that I can just jump right into binary and do this? So I'm going to go with the first thing I hear on either side. Twitch over here, YouTube over here. Enzo Bear said, we understand. All right, so I'm not going to go all the way back to the beginning, but I am going to show you guys a quick little breakdown of this. So let's say you had like a 192, 168, maybe 10.1, and it's like a slash 26, right? And you've got this number over here, and you're like, all right, what is this? What is this? What is this? What are all these things, right? There's a bunch of things that are happening here in a network, right? And to answer it is, there's 32 bits in an IPv4 address. So there's 32 bits across. But that would be really, really annoying for me to ping Google and then 110101. Like, that would be really annoying. So we turn this into what's called dotted decimal format. This is called dotted decimal. And down here would be binary, right? Binary, and it's 32 bits across. All right? Everybody get that? If you have a bunch of bits here, and you put a bunch of zeros in here, in every placeholder, you would get the number 0. And if you were to put ones here in the 128 column, 64, 32, 16, 8, 4, 2, and 1, you would have 255. Okay? So, if you were to look at this and you knew that this was a 192 in the first octet here, right? So each of these is an octet. That's an octet because it's 8, right? 8 bits. Then I say, well, in the first octet, we've got a 192. So this is a class C address. And what does it mean that it's a class C address? For people that are maybe a little bit newer, it means that I can't touch anything over here. This is granite. This basically is granite. You can't scratch it. You've got a little pen like this little stylus here. You cannot change this. So this right here, to you, if you're in a network, is set in stone. You may not change it. You're not allowed to. I have set the rules, the powers that be before me. You can't change it. But that's a /24 address, right? That's what it says right here. There's 24 network bits. And somebody in our company said, well, there's a 26. So they borrowed 2 bits right here. And when they borrowed those 2 bits, again, I didn't go all the way back to all this stuff. When they borrowed those 2 bits, they set these in stone as well. And these have, there's 4 states of nature right here in these bits. There's 00, 01, 10, and 11. That's what they are. These positional places represent right here, 128's and 64's column. So if we go and we look at this, what's a 00? It's the .0 network. What's a 01? It's the 64 network, right? And then what's the 10? That's the 128's network. And this last one, which is a 11 right here, 128 plus 64, is the 192 network, right? What does that go over to? Well, I would have, I would have explained binary more, but people said, I go with the first thing I hear, and somebody over on Twitch said they got it. So I said, all right. So the next question is, and by the way, to get 0 as your network, all of these host bits over here had to be zeros. But what if I turned all the host bits over here on? Then I would get the broadcast. Well, the broadcast would be, for the first network, 0, 0, 32 plus 16 plus 8 plus 4 plus 2 plus 1, which would be 63 in this first one. In this one, it would be 127. In this one, it would be 191. And in this bottom one, it would be 255. And some of you maybe very astutely said, wait a minute, Scott. In that last one, you cheated because you just used that last one. And I would say, yes, I did cheat. And then you might say, well, wait, 191 is one less than 192, so you actually cheated 127. Yeah, all you did was subtract 1. I'd say, yeah, I did cheat. Yep. If I didn't know this, I would have cheated. Yep. There's nothing wrong with that because you're still understanding how the system works. But I always tell you guys, when you first learn it, for somebody who's never seen this before and you're looking at it, we can't do all the shortcuts. I got to show you all the pieces. But these are the networks here, and this is the binary rundown. All right. So that can take like 3 minutes like it just did, or it could take 15 minutes. But we don't need to go back and do all the other stuff because I think you guys got that. Hey, Colchis, how's it going? And then Linux developer probably already left, but I appreciate you guys coming by and hanging out. Let's go down, and I'm going to say, why do we subnet, right? This is a question. I originally built this for this presentation, and then I use this to show this to my college students as well. So you've got a network, that network we were just dealing with, which is a Class C network. It's got 0 to 255, which is 256 total states of nature in those 8 bits, right? But 2 get thrown away. The first one is the network address. That's kind of like the sign on the front door. And then the last one is the broadcast, how we yell to everybody in the network. Well, what I was showing the other day is like this. Let's say this was a college class. And I was up. What the heck's going on here? There we go. And I'm up here, right? And I'm yelling at all of my little students. How am I going to draw students? They're just going to be tiny versions of me, right? So all my little students over here, and I'm yelling at them. But then another college professor is down here, and he's also yelling at his students, right? And in this network, as we have it, this is yelling right here. To yell at everybody, you have to yell at 255. So if I'm yelling at my college students and he's yelling at his, or let's just say we're lecturing, sure, whatever. In this network, I have to yell at 255 and he has to yell at 255. Well, hold on, Hayes. Do you know why I have to yell at my students? Does anybody here know why I have to yell at my students? Somebody here knows. I don't know if you guys have been around long enough. People that have been around me long enough know. Well, they're not going to yell at themselves. So, all right. This is why we subnet, guys. Because in systems world, everybody would have to listen to all the yelling. So what we do is we say, well, hold on. I could borrow a bit. So this is the original one. 256 total addresses, but you can't use the first one. You can't use the last one. So now I say, well, what if I borrow 1 bit? And by mathematically borrowing that 1 bit, I can split this to 0 to 127. So now I'm yelling at 127. And he, in this other classroom, I always think of Dr. Marzouk. He's one of our leads at the college. He's in some classes where we have to team up and yell at students. He is the one that I always think of here. Me over here, and then Dr. Marzouk over here yelling at our students. He's yelling at 255. I'm now yelling at 127. But it's almost like the room got partitioned. Have any of you guys ever been in those big ballrooms, or if you've ever been in the Orange County Convention Center or something? I remember that when I was a kid. Big, giant, massive rooms. But they can pull these walls out, and they can partition these big, giant rooms into smaller rooms that are still big, giant rooms. And the point is, you can build these really massive things, and you're just doing it in mathematical world, right? So what if I wanted to borrow another bit and further subdivide these rooms? I could borrow 1 more bit, and I'd be at /26. By the way, this is the same numbers that we used up there. So now I'm yelling at 63 in a smaller classroom. There's 1 to 62, so I have 62 students allowed in here. 62, another 62 allowed down here. 62 here, 62 here. He's yelling at 255. I'm yelling at 63, and we got 2 other classrooms now where more people can be yelling. Where's the headphones? Yeah. All right. So what if we went again and we borrowed another bit, right? So /27, and now you have 8 networks, and they're all 1/8 the original size. I can only have between 1 and 30 now, so I can have 30 students in here, 30 students over here, 30, 30, 30, 30, 30, 30, right? Okay. A t-shirt on it. So let's go here and let's take that example, and I'm going to break it down like I just did. So 192.168.1, 192, 168, 10/27. We know it's a class C to start, so we know that we can't touch anything over here. So really, for the rest of this discussion, I could just draw, don't worry about it. But we'll go ahead and play around. Here's the masked bits here. If we needed the mask, you do need the mask. By the way, you need to understand the mask too. So here's the masked bits. And somebody borrowed 3 bits. So here's the ones here. So now this is 255. And you say, how did you get that? Well, if you turn on all the bits to ones, you got 0 to 255. There's 255. That's 255. That's 255. And then this one is 1, 2, 3. It's a 128, a 64, and a 32. So this is 224 in that last octet. So yeah, so 255. So somebody said, what's a /27? It's 255, 255, 255.224. Now, the states of nature here are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. There's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Those are all the states that can exist if I have 3 positional places with 0s to 1s in them. There's 8 networks, right? So if I were to come over here and count those networks up, right? There's a few ways to think about this, but one is this is the 32s column. So I could think about it as I'm counting by 32. I've got the 0. Or I can come here and look, and that's a 1 there, so that's a 32. And then that's just the one after it, so that's a 64. What's the next one? It's a 64 plus a 32, so I could add them up and I'd get 96, right? And then this next one would be just here, so it would be a 128, right? Just right here, it's a 128. Boom. Then it's a 128 plus 32, so it's a 160, right? And then it's these two, so it's a 192. So it's a 128 plus 64, 192. And then the last one is all 3 of those on, which is the same as that, which is 224. Now, those are the starting network addresses, the unusable ranges that kind of act like the front door, if you want to think of it like that. It's like the room number, if you will. It's the network number is what it's called. And it lets us know the starting point of that network. And then the first one that we can use in here is the 1. And then the last one we can use is the .31 address. So it's 192.168.1.0 through 31. And 31 is always the broadcast, so we can't use it. Now, I can cheat and I can just count backwards and say, well, this one's 255. I know that because that's the last address. This is 1 less than that one, so it's 223. This is 1 less than that one, it's 191. 1 less than that one, it's 159. 1 less than that one, it's 127. 1 less than that one, it's 95. And 1 less than that one is 63. Those are the numbers right there that coincide with these network ranges. Now, I either just did something mathematically or I just cast a spell, because watch this. 0, 32, 64, 96, 128, 160, 192, 224. 0, 32, 64, 96, 128, 160, 192, 224. So I either guessed really well, or I cast a spell, or I did math. 31, 63, 95, 127, 159, 191, 223, 255. 31, 63, 95, 1. So what I'm saying is once this demystifies for you, you'll never have problems with this ever again. Like, this is something that you can understand well, and you can figure out. Now, earlier, I counted these up, and it was really easy to count these up, and I could just say right here 8. But what might be better is these are subnet bits. Is I can use this equation here, 2 to the power of 3, 1, 2, 3, is 8. And I've got this equation here, and I've got 5 host bits. So 2 to the power of 5 minus 2. So what's 2 to the power of 5 right here? 32 minus 2 is 30 hosts per subnet. And you say, how do you know it's 30 hosts per subnet? Well, that is also, we could also count here. The effective range of this is 1 to 30, right? The effective range of this is 33 to 62, right? And then you could go down and you could find what we call the first usable host and the last usable host of each of those networks. So I show you guys this to show you that once this clicks for you, you'll never have to learn it again. But I think that this clicks, and I use this, by the way, this template's up in our Discord. You can, if you want, just ask me down a network, and I'll drop a bunch of examples like this, and you can break them down, and then you can practice them. So people sometimes have practiced them you can go look at practice ones from before that people have asked for, and then people will break them down, and then I'll show them where they're right or wrong or whatever. Or if you just say, I have no idea, then I'll just break it down for you guys and show you. But this model is the one that I use. There is no number you can give me in this range that I can't break down like this and just do pretty quickly. Once you understand it, you don't really even need it anymore. You just need it when these are the training wheels as we're learning the thing. This is good to understand and be able to count up the bits, but then like maybe you don't draw this whole thing out when you go take your Net Plus or your CCNA, but you at least understand like the pieces of it. Okay, so then the next part is there's the organization. So the OSI model comes from the ISO, which is the International Standards Organization, and they built the thing called the Open Systems Interconnect model. OSI is the Open Systems Interconnect model. And the people that started it are the ISO, which is the International Standards Organization. So the ISO made the OSI, right? It's fun. It's fun. It's all fun. Boom. ISO made this. And that's the International Standards Organization made the Open Systems Interconnect model. There are 2 major reasons, 1 and 2, for this. 1 is for teaching. We can teach based on individual components, and we can talk about each individual part. And then on the other parts of it, I can say, that's not important right now. We're doing the session layer. And that's not important right now. We're doing the transport layer. And I can be precise to the sections that I want, and the other one is modularity. Modularity is the idea that if I understand how the transport layer here works, talking up to the session layer and talking down to the network layer, if I understand the protocols as they were, right, because protocols are the rules that govern how, the set of rules that govern how communication occur. If I understand this, right, if I understand how these pieces interact here, right, how they talk to each other, I should be able to replace this section right here. I should be able to I should just be able to take it out, put a new one in that follows these rules, how it communicates up and how it communicates down. And then any efficiencies that I add or any any components that I add here don't affect anything else up the stack, and nothing affects anything down the stack, because in here I followed the rules. The easiest way I can describe this, or the easiest way I think about this, is a little child's toy that looks like this. Any of you guys ever seen one of these little guys? And they connect, right? And what are they called? Legos. Everybody here know what a Lego is? And Legos, as long as you connect to them, you can just keep putting Legos like this, right? I know they're not great, but the point is you can just keep interconnecting them. And if I took this part out and I said, you know, this is blue and this is blue, and I said, hold on a second, I'm going to blow your mind for a second here, and I made this one red, right? I didn't change anything else. Wouldn't this still work, and wouldn't this still work if I changed the color? So the what did you say? The prison shift, step on a Lego. Yeah. So the point is modularity is the ability to change out components, modules, without affecting other pieces. That's what modularity is in engineering, right? So when you have a model, there's two really useful things. It's for breaking down and understanding or teaching, right? Understanding, if you want to think of it as just like going and reading it on your own. And two is modularity, and that's the idea that we can affect individual. I mean, could any of you imagine, like, if you had a cable that went bad in your home, and you went to go buy a new cable, and we're like, well, time to change out that NIC in your laptop. We're going to have to bust it open. Oh, by the way, you're going to have to buy a new router. All of you would be like, what the hell? Doesn't even make any sense. And I'm like, them's the rules. There's no modularity. We gotta replace the whole thing. No, we want to be able to change one little module out, right? I don't know if any of you guys, this is the one thing I was explaining this to my wife the other day. One of the reasons insurance costs have gone up so much. Has anybody here was driving like before the 2000s? Yeah, right. Some of us were. Does anybody here remember when your light bulb would go out in your car? You would go out and you would pop, yeah, or your car does, right? Yeah, your car remembers. And you would pop the light, you would pop the whole fixture out and you would just replace the light. That was very modular. But nowadays, some of you guys have newer vehicles like my truck. If I want to go replace a component on my truck, like that, you know, front like headlight, that whole assembly comes out and they put a whole new one in. You don't get to just change out the lights anymore. Now, they're LED lights and stuff, so they never go bad. They come, you know, from the factory that way. I didn't put silly LED lights on my car. But the point is that component very rarely fails, so it comes apart. Well, the reason this has affected insurance prices so much is back in the day, if me and Enzo Bear's cars ran into each other that were from before the 2000s, it was like buff the fender out and go along your day. And if you need to replace just the casing over the light, you just replace the casing for $14 or something. It's nothing. Dent out the car a little bit and you go. But nowadays, you break the lights on my truck, I think that part is like $750, maybe even more, to replace that stupid little, that one little part of my truck costs that. So insurance costs are, like, even fender benders shoot way up. I remember replacing your radio. It was really popular because it was standard. Yeah. And actually, yeah, we used to replace radios in cars in the 90s. Me and my friends, we would go and, you know, you go buy a little bit nicer, and then we'd have to take the faceplates out because back then, like, I don't know whatever happened to car stereo thefts, but I feel like I don't hear about them nearly as much as I did in the 90s, because in the 90s everybody had their car stereo stolen. But if you had the little thing where you could take the faceplate off, most people didn't want the other component, because that's also technically modularity too, except you couldn't put some other faceplate on it. You could only have the one for that vehicle. So all right. So anyways, that was a thing. It used to happen. And then, yeah, you'd go and you'd plug your faceplate back into your vehicle when you'd get back on, and then your radio would work or whatever. I don't know if probably only a few of us remember that, but yeah. All right. So anyways, OSI model basics, that's how they work. All right. So there's the way that the data flow between the two systems are as follows. On one side, the data flow down, and as they get to right here, there's protocol data units throughout. So there are little things called protocol data units. Protocol. What the heck? Where's this at? Come here. Boom. All right, there's my pen. All right. There are things called, oh, I was going off the thing. protocol. These right here are protocol data units, PDUs, right? Not to be mistaken with power delivery units or whatever the heck they are in data center. You'll hear PDUs all the time in the data center, but they are power units there. Here, they are protocol data units. And up here, it is simply called, anybody here know what it's called up here? Simply called data, right here. At the transport layer, we start to call the PDU segments, because there's a header applied to the data, and we start to look at them and say, oh, I have it right here, data. All right, anyways, I made these so long ago, I don't even remember, but I did draw these, so segments. Then we add a header, and that header is now is called a packet. But what I could draw here, what I probably should draw, is this is the header being applied to this. The data over here, whoops, the data over here is all of the segment and its header in the data portion of the packet. Then as the packet comes down, right, it becomes a frame as the header is applied to it, and for the first and only time a trailer is applied. Over here then, all of this becomes the data within the frame, right? So it's just raw data up here coming down. There are things happening to the data here, though. At this, there's windowing, and here there are three things that happen here. We'll get to them, but it's encryption, encode, and compress. And just as a real quick thought experience as engineers or people that want to be engineers, what do you think if I encrypt on one side, encode, and compress on one side, what logically has to happen on the other side for the message to get to the other person up here? What has to happen on this side? If I'm and maybe I've already shown my hand too much today, but if I'm doing something down one side, what do I have to do to it on the other side? Who knows what has to happen on the other side? Jeez, can't even decode my own handwriting. And yeah, I bet I see it over here. Yeah, it's you have to undo whatever you did. So if you encrypt, encode, compress, then you have to decrypt, decode, decompress. And these are going to actually, it's funny, the presentation layer is so filled with things you guys know. And we could sit here, by the way, we can sit here and just spend time here. We can say like HTTP, right? Which we haven't talked about yet. DNS, which we have talked about. DNS, FTP. All kinds of protocols and things that you guys are somewhat familiar with, SNMP, right? Different ways and there's all kinds of things. And then presentation layer are all kinds of things you've heard of. It's like MP4, all of the protocols for that. There are codecs. Codecs don't need a dot in front of them because they're not a file system. But all of the things that you know about video encoding and all of these things, all of the voice encoding that some of you have never heard of, what are called the codecs, those are all here. Massive amount of things happen up here. Sessions tend to be windowing and flow control in relation to the segments that are coming through from one side to another. So windowing is how much or how many, and then how many so it's how many before acknowledgement, And then flow control is adjusts window. Don't worry about all the chicken scratch. It all gets wiped every time I do this anyways, right? But the point is windowing and flow control happen up here. Windowing and flow control in the session layer only affect TCP, by the way. TCP only affected here. Because as we get down into UDP, you find UDP doesn't have UDP doesn't even know, nor does it care how the data gets there. It just launches it. Just as the younger people say, yeets it over the wall, right? It just launches. I thought it was going to say yeet, right? Doesn't matter. I'm getting loopy. But anyways, we come down here and then, yeah, transport network. And again, if I were sitting and this is a primer, so this is like this is a super most basic of knowledge of this. I'm not trying to make you guys experts in any way. That was at the beginning of this presentation. But we could spend, time on each of these, and we could spend a lot of time in these sections. Like I could spend days talking about each of these sections because there's a lot of depth to them. So what I did instead in this primer, as we get into some of these, what I did instead of digging into them too far, is I showed you what the IETF RFC 4, that's the Internet Engineering Task Force, RFC is. So I can click on this and I say skip verification and pull this up. And here's the IETF RFC that talks about transmission control protocol. And let's refresh that. And then here is all of the information about, we'll leave it at 1, all about that. So if you were like, hey, Scott, can you give that to me? Sure. They're free. They're all over the internet. But these are the things that'll help you go to sleep at night if you have problems going to sleep. If you're struggling with getting to sleep. Let's check on Ranger. Ranger is still not back on his bed. Where is that dog? He sometimes, there he is. He sometimes lays, guys, right on this rug over here. He likes hanging out on the rug too. So let's see which bed he picks. Do I pick my smaller bed down on the floor or my big king-size couch up on the nice bed? What am I gonna, he's going to lick his bed for a little bit. We'll keep an eye on Ranger for a second here. But all that stuff to say that, this is how the OSI model works. A lot of information, lots of things. Like for you that want to go and say, hey, this is interesting. I want to go be a network engineer. You're going to go spend your time learning this for some time. And for those of you that are like, oh, I want to be a systems engineer. I want to be a programmer, but I want to understand this stuff. Yeah, this is about as deep as you need to go on a lot of this stuff. Again, that book, the free book from IBM Red Books, that book is there. I think that stands as a really good little primer for about 170 pages or so. And there's a lot of pictures. So 170 pages with pictures, probably got about 90 pages of actual reading. Most of you could probably tackle that in an hour or so, maybe a little over an hour. Spend some time with it. If you actually dig in and spend some time with it and go do some reading, probably spend a few days in there, actual reading and learning some of this stuff. But the point is, this stuff's only magic until somebody shows it to you, and then you're like, that's it. That's all the stuff that's happening. That's it. It's all stuff that needs to happen. And I can look at it anytime I want with like Wireshark. Yep, that's it. It's all here. Nothing's magical. It's all here. It's all the ones and zeros over here. You can even change the default set, like the view. You can change how this is shown to you. This is in hex right here, but it's based on, here's the broadcast, all the F's in hex right there. And you're like, well, but I want to see only the first half of the locally administered address there, and I want to see the group address, which is also the broadcast. That's right here. Yeah, anyways. I don't know why that one's not switching down there. Maybe there's a bug. But anyway, so there's all that. So that's kind of how that all works. All right. So then we get into, in this, I took all this that I drew and I turned them into individual things. So as we're talking about each layer, I have it up here in the corner which layer we're on. So if you're like, Hey, where's he at? Well, we're talking layer 7, which is the application layer. By the way, people learn this different ways. I'm never gonna like say, hey, don't go learning some, you know, what do they call them? I want to say anagram, but that's not the right term. What's that called? Where you learn. It's not a homonym. Somebody help me out here. What's that called when you take all of the? I'm drawing a blank in my head, but like people learn, all people seem to need data processing, or please do not throw sausage pizza away, or please do not. Or yeah, please do not touch Steve's pet alligator, or whatever. Yeah, yeah, mnemonic. That's what it is. Yeah, mnemonic. And look, I'm not gonna say don't learn that way. I'm just gonna tell you when you touch this stuff enough, and if you do this as a engineer and decide to make that your career, you're not gonna need the mnemonic anymore. But it's a good, it's a good place to start, I guess. But I would spend, instead of learning all those, because there's like 100 of them, and some of them are really dirty, learn how the data kind of flows without all my notes everywhere. And then I think it'll stick more. At least that's my thoughts on it. But then again, I learned it with the all people seem to need data processing, or please do not throw sausage pizza away if you want to go from bottom to top. I mean, whatever, right? So here's some concepts you need to know. You need to know if you're going to take like a CCNA or a Net Plus, and you also do need to know this from a network engineer standpoint, because the reason you need to know port mapping is this. The Linux engineers, me, and then the guys above me, and when I say above me, I mean on the platform, like higher up in the layers, the guys that are the software engineers and the DevOps guys, they don't care what port it is. They are going to tell you HTTPS is not working if you're a network guy. And you're going to have to know that they are trying to talk on this. So, hey, Sid, how's it going? How was your stream? I don't have anything cool with, like, raid or anything like that, but that's about as long as I can do it. But you guys are raiding into me hanging out and doing some Linux. I got asked by Enzo Bear earlier. I have a really high channel point redeem to go talk about any topic that I've talked about before. So what you guys are raiding in on is a talk that I did. I did a primer on this for my Linux engineers a while back, where it was like, how does networking work? Because some of you guys know I've been a college professor for 16 years on networking. I've been a Linux engineer and high performance compute engineer for about 22 years. So this is a high level talk through networking. It is not designed to make somebody an expert, and is not designed to go deep in. It's just, how does networking work and those kind of things. So this is what you guys rated in on. There's actually a recording on YouTube that I did of this years ago when I first presented it, and I scratch all over the page. What we were getting into is port mappings. But here's the fun thing. If you're not taking a certification test, you don't need to memorize these. This is the old, you never have a calculator in your pocket. If you said, Scott, what's HTTP in a Linux system, I would say grep HTTP from Etsy services, and there is a file inside of Linux that maps everything to everything. I imagine there's one in Windows, but I don't know it. Not right off anyways. I could probably go look it up. But all of my stuff is going on right here. And here's HTTPS, which happens to be 443, and sometimes 8443. Sometimes we use that. But this is what we were doing. We were just talking about networking and systems and all that kind of stuff. So I appreciate you dropping everybody by. I don't know if you got to go or if you're going to be back on around later. I am in bachelor mode tonight. I got to figure out what I need to eat here in a little bit, actually, because the wife is up in Utah. By the way, guys, Sid, I'm not outing Sid in any way. I'm pretty sure he tells his guys that he's in the Arizona area, and I'm also in the Arizona area. So we're in the same general city. But I know that because one time he was out of town and we were talking about it and stuff, and I think he was drunk, but he probably remembers telling me that. But anyways, he was out doing a job like about a year ago on something, and he was hanging out like in a bar or something. I don't know. He was drinking and stuff, and then we were talking. Oh, and then he had this walk home. I remember this walk home from Sid. This is one of my favorite Sid heresy things. If I can tell them about you a little bit, if you're still around. he was walking, and he looked on his app, and he goes, "It's not that far of a walk." And then he was walking on stream for like fucking an hour and a half, guys. And I'm like watching this going like, Sid, are you sure it was that close? And he's like, oh, it was only like 8 blocks. And I'm like, look, man, I'm watching you walk, and I've seen you make a few turns. You have walked over a mile, bro. So he was like, it was kind of funny that he was out of town though. He was yeah, in Phoenix everything is too far of a walk for sure. But he was out of town somewhere. And I just remember, like, he was walking, and I'm like, holy shit, man, how long are you going to be walking for? Like, I was tired watching him walk. Anyways, it was funny. It was late at night one night. But anyways, I'm hanging out because the wife is out of town, so I'm just kind of streaming a little bit. I hadn't streamed all week, so I thought I'd hop on here and do this. So anyways, you don't have to memorize all the port numbers in the Linux world. Let's check one other one. I don't think this one's captured anymore, but the Doom port... Yeah, it is still the Doom port. So if you guys aren't familiar, there was a game in the 90s called Doom. It's still around, but it used to be Wolfenstein 3D, and then it was Doom, and then now it's still. I think they're still making Doom games, right? Some of you guys are still playing Doom and running around and killing the demons. If you guys have played it, well, the port that Doom used to run on over the network is 666. So they took the Doom port. So if you guys didn't know that, that's kind of a fun little one of those internet things. Yeah, because Phoenix walking is not nice. Yeah. I just remember him looking on his app, and he's like, it's not that far, and he was kind of toasted. You could tell he was pretty licked up, and he had drank quite a bit, I think, on stream. So he was walking back to his hotel, and just took forever, and it was kind of a funny Sid thing. But yeah, and okay, so that's all this. I wanted you guys to see this because, again, you don't have to memorize your ports. Your ports are there. You can, but it's good to understand how ports work and what the default ones are. Now, if you tell me, hey Scott, of these port numbers, which ones do I need to know? Well, I would tell you to do like a more on Etsy services, and then I would tell you that between 0 and 123 are what are known as the well-known ports. 124 and above are your 1024 and above. 1024 are you could do pretty much whatever you want in there. But 0 to 123 are your well-known ports. And you do need to kind of memorize some of these if you're going to take a Network Plus test or a Security Plus test or any of these. And when I say you need to memorize them, you need to be able to pick them out of a lineup. Let's say it like that. Like could you pick Scott out of a lineup? Well, if the guy's not wearing glasses and he's not wearing I think it's a black shirt. If he's not, I have black and navy blue shirts mostly. So let's say a black shirt, and he's not, I don't know, wearing like a dark wedding ring. It's not Scott, right? You need to be able to at least do that. And what I mean by that is like FTP is always 20 and 21. They might not make you memorize the difference between the FTP data control, which is 20, and 21 is FTP, but they might have a thing where it's like 20 and 21, 27 and 28, 35 and 36. And really you just have to kind of know, like, well, none of those other ones make any sense, right? It's 20 and 21 that are paired for FTP, right? And really, by the way, you won't ever use either of these because that's insecure. You would actually use secure FTP over port 22, which is actually done just a trick at that point. But Hayes, you said I live in Phoenix once, had a 15-minute walk from office to house, and I thought I could walk home for lunch my first day in July. I made it 1 block. Yeah. People don't realize, like, the memes about how hot Arizona are, and especially Phoenix area, they're not jokes. Like, like when you see the guy come out in, if any of you guys ever go rewatch the show, I love this show, Arrested Development. And he goes to he's spiting his family and decides to leave the family, and he moves him and his son to Phoenix, and he goes out and he's like looking, and it's like really hot, and he goes to grab the handle of the taxi, and the guy's like, oh no, and he touches it and he burns his hand, and he just turns around and goes back inside the airport and leaves. That's exactly like being in Phoenix. It's and one of the most painful things you can do in Phoenix is if you have a steering wheel that's out in the sun, and you happen to, and some people will wrap their steering wheels. There's these things you can buy at like AutoZone that you can wrap your steering wheels. But I can tell you right now, if anybody's ever done this in Phoenix, it's painful. You'll get in your car, you'll be like, okay, it's cooling off. It was 130 degrees on this black top, whatever. It's very much hotter in your car, probably about 170. You got to dodge so you don't burn yourself on your, because if you touch the metal of your seatbelt, you're definitely going to burn yourself. But this is one of the things that's super painful is you'll go to drive out of there, and where your hands are not that hot on the steering wheel. You're like, oh, okay, I can touch it. And then you go to turn, and you let it slide back through your hand, and all that heat goes into your hand. So you drive, and then if any of you guys have ever turned and you like let the wheel slip back through your hand, it feels like a knife across your hand because it's all the heat from the steering wheel right into your hand. It's terrible. Anyways, yeah. So Phoenix, it's not a joke. And they did a King of the Hill, too, I think, where he goes, this is a monument to man's arrogance. This city shouldn't exist. That's true as well. Right. Anyway, so this is the very, very hot city. Anyways, where I'm going with that, I was back on this. These first ones, probably up to about one, let's see, it's one. I would know most of them up to here, or I would at least know up to probably 161 SNMP. These are the ones you're probably going to get asked about. SNMP for sure. NTP you might see. And NTP has certain vulnerabilities. So like in a Security Plus, you might get asked about how you control NTP and what some of the problems are with NTP. And NTP has, there are buffer problems that still exist in the protocol that can cause problems with your system if you go out to the world to uncontrolled NTP sources, right? POP, you definitely need to know post office protocol. I'm used to POP 3, which is 110, so you probably want to know that. And then HTTP for sure you need to know. You don't really need to know these. TFTP is 69. You should know that one. Just because TFTP is still used, especially in networking. A lot. I used TFTP 3 days ago to upgrade a switch's firmware. So TFTP is still a thing. SSH is port 22, 100% you need to know that. And Telnet's a good one to know, even though we don't typically use Telnet. We haven't used Telnet in the world for over 15 years. But Telnet is still a protocol that you need to know because it may still exist on your system. And the reason we as systems engineers use Telnet is to test for open ports. But if your security doesn't allow it, which they shouldn't, by the way, NC, Netcat is the other one that we use for port. But don't worry about that. SMTP, mail, and FTP. Those are the main ones I would know. I wouldn't say you have to memorize any of these ones. In fact, I don't even know any of these ones. But kind of the ones that I mentioned are good. There's one other one that comes up sometimes, which is you might just grep LDAP from this. LDAP is a very common direct, and HTTPS, which is 443 as well, or 8443. Also, sometimes web is 80, but it's also 8080 sometimes. So, but generally, they're not going to try to get you on those ones probably. But I'm 100% sure that they ask these type of questions on a lot of Security Plus. Like, what is LDAP? It's Lightweight Directory Authentication Protocol, and it's the way that our Linux boxes authenticate and talk into Active Directory systems. Now, some of you guys might think like, oh, Scott's a Linux purist. He would never use Windows. Obviously, I use Windows to get into systems, and if the government system or whatever I'm talking on requires me to jump through a server or whatever, I will. But LDAP, where I'm going with that is Active Directory has won that battle. Guys, Active Directory is the best fucking place to just drop users. If you're a company and you don't want to deal with it, Active Directory has won that battle. We don't have anything in the Linux world. You say, oh, what about NIS? NIS is absolute garbage. I've run NIS in one system ever, and that was 20 years ago. NIS is Network Information Services. It's our answer for LDAP. Absolute garbage, flat file nonsense, right? Active Directory is better. Also, Exchange is better than most of the mail stuff. You do your own mail stuff, but I'm saying for a company that wants security built in, Exchange is better, right? Like, if you don't want to be in the business of dealing with a bunch of web server crap. Anyways, LDAP and LDAP-S, which is the secure LDAP, these are ones that you do need to know right here. So it's how our Linux people talk into. And by the way, I also tell you guys this often. as Linux engineers, we do not want to be in the business. You do not ever, yeah, DNS is Route 53, or 53, right? DNS. You do not want to be in the business of identity and access management. Identity and access management, IAM, is its own security function within a company. It is a security function, it is an HR function. It is over there. Who is allowed to touch what? And we just want to authenticate into the service, LDAP, into Active Directory typically, to allow us to do that. So what I tell you guys often is, for me, I set my Linux systems up to talk to that and then trust whatever information's out of that and give my users the ability to do things so that I can be far decoupled, right? This is modularity. I want to be far decoupled from having to worry about identity and access management issues. If a user is allowed to be on my Linux boxes, my system gives them that access through the trust that I've built with my LDAP into their tool. I don't want to be any more involved than that, guys. Misconfigured NIS stuff. Yeah, Kithral, I'm surprised. I mean, I would be willing to bet that NIS environment is very much like either air gapped or off, like just some Unix admin still running it, because I can't imagine like integrating that with a company thing. It's a hassle. You won't be asked. Yeah, you probably won't be asked much other things on that. But yeah, how did I miss 53? DNS, very important. DNS is huge. 53. All right. So all that to be said, that those are not all layer 7. Only the layer 7 ones are layer 7. So HTTP, HTTPS, DNS, these are ones that I think you need to know on the Linux engineering side of things. Common devices that you're going to interface with: web application firewalls, reverse proxies or load balancers, and then next-gen firewalls. We talked about proxies earlier, so we won't go over it again too much, but a proxy does things on behalf of you. A reverse proxy does things for your servers on behalf of the clients, right? It almost acts as like it is customer-facing front end to extend the load balancing, or what we call high availability of our servers, right? Because I could take one of these down and the other two are still serving for our clients, and they are none the wiser if my reverse proxy is set up right. And we talked about, and then firewalls. Layer 7 firewalls are different than layer 4 firewalls. Layer 3 and 4 firewalls that you're going to run into later on in your career. Hold on, the wife just texted me. So she was telling me, when I just talked to her on break here, so I was talking to the wife, she said that our grandbaby Ezra had a lot of fun playing Chutes and Ladders and some other game. And I was like, well, you should get him Castle Panic. But does anybody here know what Castle Panic is? Does anybody here know, like, anybody here play board games? I don't know if any of you guys play board games. Love board games. I have a whole wall in my house of board games. It's a couple hundred board games, right? And one of the games I love showing people, especially if I have like guests over, and we field a team of at least 6 people, like if you have a few couples over, like couple, groups of friends, right? Because when you're married, you basically hang out with like your married friends a lot. We play this game called Castle Panic. Does anybody here know what Castle Panic is? Well, anyways, Castle Panic's great. There's a version of this game for kids, though, for younger kids, called My First Castle Panic. And My First Castle Panic, the wife just ordered for him. And it is this little game where, so in Castle Panic, you are all grouped up trying to defend your castle from monsters. And then the one for the kids is much more based on, it goes really young. I think it's all the way down to, how young can the kids be for this one? Yeah, 4+. So he just turned 4. His birthday was yesterday. So it's a fun little game, and in this one it's colors and shapes. So they get to practice colors and shapes while they snuff out the life of monsters that are attacking their castles. In the real game Castle Panic, I love this game. This is one of my favorite games to show people. This one is you're all teaming up to kill these monsters off, and the monsters, as they walk towards you, they have little life indicators, and then you rotate them as you hit them. But you have to work together as a group to be able to kill these monsters off. It's a pretty fun little game. I'll link it to you guys. If you've never seen it before, I want to say it's about 15 years old, but it's such a fun game. I'll link that to you guys if anybody's interested in that. But I don't know how many people out there love board games, but my family, we definitely like board games. We definitely enjoy. How's this going? By the way, you guys have access to this. This is in the Discord. If anybody wants to draw on that. All right. Unified threat management, multiple layers of security appliances that protect your system. We typically call those UTM, Unified Threat Management Systems. Then there's next-gen firewalls, and these next-gen firewalls are application layers, so they're up here at application layer. And they're aware of what the application is doing. They can adapt to various applications, users, and devices. They look for well-formed application requests, and they look for multiple concurrent connections. So they're doing stuff like, let's say you came into, my system, and you do an http://scott, .com, and then at the end of it, you say like, I don't know, you look for some path, like maybe you look for, this would be a good one, PHP info. Anybody remember that? Anybody know what a PHP info? Most people don't build pages with PHP anymore, right? Like, in fact, I don't even know where all the animosity for PHP came from, but I know a lot of people, we already got some, that dislike PHP. But PHP info, right? This was a page that when you were setting up PHP, like when I used to run LAMP stacks back in the day, PHP info would be a page that I could dump that would show everything. But some people would just leave that page up. So now that may be like a bad page. Or they'll put the, what is it? They start putting question marks and then they say user, maybe user equals and then like root. Or they just start trying just weird stuff. There's any number of weirdness that you can put in as part of the header. So they are well aware of what's called well-formed application requests. Let me show you. Let me show you an example of this real quick. So, what would be in this sense right here? Let's go look because I have good examples of this. Let's look at my Ranger Cam right here. So Ranger Cam is 192.160.11.219 in my home lab, and then it's port 3000. That's the port that Grafana listens on, and then look, there's Ranger. Then there's a path that's expected for Ranger Check Cam right there. And that well-known path is going to be learned over time by my firewall. In this case, my next generation firewall. It's going to learn that. And it's also going to learn that, well, when people do !org ID 1, that is always going to equal maybe this organization. And maybe I start splitting my Grafana out to different types of organizations. And a next-gen firewall may be aware that like org ID 2 can only be reached by certain systems. And some of them you program, and some of them actually will learn this stuff over time. There's like kind of like how Splunk has built-in AI that starts to detect things over time based on like it's just churning through all this data all the time. And it starts to notice that instead of only 1,000, you got 1,000 443 requests coming in for HTTPS, and then every night at some point you get like 16,000, and it just starts to track that, and then it just starts alerting you like, hey, this is a warning, but did you know at like 11 a.m. or 11 p.m. when people are all in bed, like you get this massive surge of spike of traffic? That might be a big thing. That might be a problem. Or it's very possible that 11 p.m. in my time is when maybe I have a customer base in India that comes to my stuff and they all check in at 11 p.m. to do their online shopping or something. I don't know, whatever site we're running, right? But the point is, maybe this thing can become more aware of that. And that's what next-gen firewalls do. And there's all kinds of stuff built into those. There's all kinds of different stuff going on with next-gen firewalls that you can go look at. But my point is they can look for things that aren't supposed to be here. Very common old one was this. Does anybody know what this is trying to do? Here, I'll draw this one for you. By the way, when we've done this talk before, have you guys? I've never shown this stuff before. Like I've never drawn this stuff out. But let's say you did this. This one's a fun one. Who has seen this in their logs recently? This still pops up in logs. It's been patched out for almost 20 years. Who knows what this is trying to do? Who knows what that is? One, if you're a Linux admin, you know what that is. But who knows what that's trying to do? Right there. This has been patched out of Apache since early 2000s, maybe. But what is that trying to do? Anybody seen that in your logs? I might be able to pull that up in a log right now somewhere. That may be in my system, so not the scott.com. That's just a made-up one. But who knows what the ... is in Linux world, right? We're doing Linux, even though we're on networking because we got asked to do networking, right? But what's the implication of ... Yeah, that's exactly what it is, Hatmoto. It is a directory list. So ... is my parent. So if I'm in a Linux system, right? You guys, this is a Linux primer, right? Where am I at? I'm in Etsy DHCP. If I say ... I'll just be in Etsy. If I say ... again, I'll just be here. So the document root, if we have a var www HTML, let's go put it on the server. Let's go to this guy. I don't think there's any there. Yeah. So DNF install. Just put HPD on here real quick. His direct, yeah, it's path traversal. It's going to the parent of 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 the parent. Try to get as high as he can go. If you put a directory nowadays, the way this is patched out is this: cd to var www HTML. This is where I would put my index.html for this page, right? And then if I cd to Etsy HTTP, and then I go to conf.d conf. Yeah. Should be in here. We should see the document root right here. So here's the directory, var www. Here's document root, var www HTML. So the furthest any of these things can ever go up, what is considered the document root of my web page, in this sense, is var www HTML. So nowadays, this is as far as they can go, is var www HTML. They can't go any higher. But back in the day, you could go and you could traverse out of the pathing of a Linux server and then do an ls, and it would read you whatever was in those. It was ridiculous. But this has all been patched out. Long time ago, guys, this was patched out. But that is still attempted by bots on the web. 100% still attempted all the time. Every production local, we'll stop this out of the box because it's obvious. Yeah. This has been patched out, again, probably close to 20 years. But I'm telling you, bots still try this. I still see this in web server logs nowadays. And it's funny because it's like, if somebody comes along, and guys, we've been joking around about this in the systems engineering world for the entire time I've been doing it, is new guys come in and they don't know why a thing is the way it is, so they patch it out from some team or some whatever. This is gonna happen. This is gonna happen with the HTTPD daemon one of these days, or Apache daemon. HTTPD is the fork for Red Hat, but HTTPD is the fork for Red Hat. Anyways, I'm trying to get my stupid thing down there to talk right. One day in the future, enough people are going to have retired that people don't remember this, and somebody's going to go, why doesn't that? And they're going to patch it out, or they're going to do some patch, and they're not going to include that anymore. And patching always introduces new vulnerabilities because of the fact that other knowledge was lost. And you might say, Scott, I can't co-sign that because knowledge isn't lost. It sits there. And I go, yeah, well, but we have empirical like proof that this happens all the time in the systems world. We patch new things to fix things, and old stuff goes away, and it becomes a problem again. And you're like, I swear to God, that thing was fixed 100 years ago. We don't have 100 years of computing really yet, but I've been watching stuff come back for years, just going, are you fucking kidding me? Is this back again? It's this. We learn our lessons and then we forget them. There's an old saying, by the way, and this is not an engineering saying. This is, I think, a maybe discipline saying, but it's lessons learned through pain are forgotten as the pain fades. There's like an old saying like that, and it's true. Like, we forget why things are like that. Anyways, all right. And then the last one of these, I could talk about these for a while, but web application firewalls. And they are sometimes provided by cloud providers will do them. You can run your own web application firewalls if you want as well. But a lot of times we terminate connections there and then allow traffic only from them into our load balancers or whatever. And we do that. And you say, how do you do that? Well, you do that through certificates and zero trust. So we have a system that will only allow a system that has a certificate to talk to it. And then users will come in, they will hit the front end of this web application firewall, they will hit filter rules, and they will only be allowed back if they are supposed to be in there. Web application firewalls focus on this thing called OWASP. Not 100%, but this is a good thing to study. I tell people all the time, if you don't want to be in deep in security, but you want to learn some security topics, maybe to be able to say, hey, like I'm a web, one of our guys is a web programmer, right? Robodom, when he's around, he does web stuff. He does front end. And he went and got a Security Plus last year, right? Or, yeah, it was last year. One of the things about that is I told him, I said, when you're doing your front end stuff, when people say, well, you got to be security focused or you got to be whatever on your interviews, one of the things you want to be able to do is come in here and say, these are the things that I understand how to protect against. These are the OWASP top 10 is the top 10 web application security risks. And now he's writing web application stuff, and he wants to prove to a company that he is security minded. These are the things you want to understand. Also, injection, broken authentication, these two right here, they're making a new list right now too. I think now until December 2024. Oh, so that's already passed. They're going to do the first half of 2025. So the new ones are coming out because these get dated, right? But here are where the problems were. Broken access control and cryptographic failures were the top two in 2021. So they show where they moved, right? This comes from surveys of programmers, surveys of systems engineers, and also web data that's given. So these lists are big and they're compiled and stuff. Then they've got a separate one for APIs. And the top two problems with APIs comprise over 95% of all compromises of APIs. Did you guys know that? So the OWASP top 10 has 10 API. There's an API version of this. And when you go look at it, the top two, broken object level authorization and authentication, those are 95% of all the problems right there. And then here's all the other ones. But these are, like, if you run APIs that are exposed to the world and you want to lock them down, you go learn about these. Right? Simple. Well, it's simple-ish, right? You still got to learn about them. But my point is, that's what these things focus on. Like my side of things, and for cloud engineers and cloud security people, which I also do some of, I also have my AWS security certification, if that matters, even though I don't do anything with AWS right now. This is their web application firewall in AWS. You got good users and bad users. And these attackers are almost universally bots. One of my buddies comes and talks to the group every now and then, and he does data analytics from Google. He does all the Google stuff for a big web page that does about $1 billion a year in sales of like office stuff. And he says, we've got all these bots. He's came and done talks and stuff. His name is Jared. He's came and talked to you guys a few times. All his talks are up in the Discord, by the way, as well. But he shows about how the bots come in, and like 15% of bots are actually good bots from vendors and people that they are in business with, coming to scrape the prices so that they can post them up, and then maybe they're value-added resellers of products or something like that, and they want to automatically scrape and be able to generate quotes and all these other things. Because maybe like his company sells the office furniture, but another company might, sell office furniture at a slight markup and then also put it all together and deliver it to your company. That might be their service right there. They'll come and install it for you too. So, to do that, they obviously have to be able to scrape the page and do that, because nobody's going to go manually populate all that. Well, anyways, where I'm going with that is you got valid users and attackers. They come in through the web application firewall. Everything's logged. Logs go to Kinesis Data Firehose, which, again, we're not going to get too much into that, but Kinesis Data Firehose functions as a buffer. When the buffer fills of either number of logs or kilobytes of logs, sorry, not number of logs, it's time in seconds or kilobytes, then it falls over and it dumps over, and then there's all this stuff happening. If a request is good, it comes to CloudFront, hits an application load balancer or an API gateway, and then there's all these things that can happen over here. And when I talked about this last time, I went heavily into like SQL injection, because that's one I've dealt with with web application firewalls, and we were talking about false positives, because there's false positives all over the place. You don't want to be blocking things that should be coming through your system, right? But anyways, this is a way that this kind of looks. You can allow and deny things based on IP sources. So maybe I don't do any business in my company with, maybe I'm not allowed to do business in my company with anywhere from Russia. Maybe that's a thing. We don't ship to Russia. We don't have the capabilities. There's a war going on. There's all these other things, so I don't ship to Russia. I can have a denied list against blocks of Russian IPs. That's a common thing. Now, could they go on a proxy and go somewhere else and order it? Maybe, and maybe they can get it through, but we don't deliver to them, so now they're going to have to deal with it, and that's on them, right? But the point is, there's all these types of things that you can do in here, and you can go spend time, learn about those if you want to go deeper in on that. This comes directly from the AWS WAF page, by the way. All right, so what happens at layer 6? This was something we talked about earlier. We encode on one side, decode on the other. So if I encode in an MP4 format, well, that MP4 format better be what you're trying to decode on the other side. If I compress with a bzip function on one side and you try to decompress with gzip function on the other side, it's not going to work. And if I encrypt on one side with like Blowfish something, right, one of these Blowfish protocols, which I always tell you guys, go look, if you want like an interesting story of the web, go look at like Blowfish. And go look at, because they used to have these encryption competitions. I don't think they still do them, or if they do, they're much more quiet about them. You probably have to be in the, maybe involved with like the teams that are working on them. But the guy who did Blowfish, he's one dude, and all these other people are like these teams of mathematicians and cryptographers and all this stuff. And the guy that like did all the Blowfish stuff was one guy. You can go look it all up. It's kind of interesting. But the point is, if I encrypt on one side, I have to decrypt on the other side with a similar thing. Now, encryption and decryption are a little weird because I can't just say you do the same thing on each side, but I can tell you if it's a symmetric key encryption, the key on one side is the same on the other. If it's an asymmetric key encryption, it must be the private key on one side and the public key on the other, or the public key on one side and the private key on the other, for that kind of stuff, right? But that's the kind of stuff that happens at layer 6, right? Encoding, decoding, compression, decompression, and your encryption and decryption happen there. All right. And on the fun side of networking, that's about all you need to know. That you could go deeper into that, but that would deal with the protocols and some of the other stuff. And you see them a little bit here. If you go, like I'm going to go to one of my talks that has... here you have session initiation protocol. SIP is almost like the DNS of calling for voice over IP. So it's session initiation protocol. There's an invite, then there is an acknowledgement, and then there's a 200 OK. And once that happens, the call has initiated, and then we start to get this real-time transport protocol here. Real-time transport protocol is great, but it's not secure. So this was actually a phone call that was captured as part of a lab that I ran. So this is actually funny. I can play this back. I can come in here, and I can go to voice over IP calls, and I can play this call. Now, I need to mention something. I am sitting alone in my house right now. My wife is not here. And this is the creepiest voice I have ever heard. That's going to say, hello world. This is creepy. So hopefully you guys can hear it. Creepy. Hold on. Just. Like, if I woke up to that, that would terrify me. Like, if that voice... All right, I'm going to do it one more time. Creepy. All right. Anyways, but the point... the point is, you get into the codecs. Hold on. I wonder if I could see the codecs up here in the real-time transport. Yeah, so the payload type is ITU-T, ITU-T G711. G711 is a very common codec. Hold on. Those things are creepy. G711, hold on. And you can go and read all about this audio codec. And if you happen to be somebody who is doing voice over IP, so back up a second. A lot of times on stream here we're talking systems engineering, but remember I came from a network engineering background. So when I was doing college and stuff, we would be using different codecs, and we would have like a certain level of quality that we would want for our calls. We would want a certain level of compression, and then we would also want to know the number of calls that we could make out of a call center on a line, assuming that each call was X amount of minutes. There's all kinds of equations for this stuff, right? It's not super difficult, but the point is there's different versions of the protocol that also go further. There's the sampling frequency, so it's got an 8 kilohertz sampling frequency. It's a 64 kilobit per second bit rate, but that's only when it's transmitting. There's actually, you guys might not think this because you're listening to me and you're like, man, this guy hasn't stopped talking for like an hour, right? He's just rambling on. But even in my voice, even as I'm talking to you, probably about half of the time is dead air. I don't know if you guys know that. You might be sitting here and you might be like, man, I can't listen to that guy for one more second. Well, if you've been listening to me for an hour, you've only had about half an hour of my voice. And that's a funny way to think of it, right? Like, we've been sitting here for 4 hours, but we've only been talking for 2 of them. But that's true. When you talk about compression of signals and stuff, guys, there's lots of maths if you want. But again, this is what I tell you guys all the time. Noise everywhere. Yeah, I tell you guys this all the time. If you don't want to know any more about it, then just know that it's there and go troubleshoot it when there's a problem. The reason I got into the systems engineering part is because also sometimes M-Pesa hangs out with us, and sometimes he's even on here, and he's down in our Discord a lot, and he's a guy that I've known for a while. But I worked with his dad and him at AAA, but his dad was in charge of all the voice stuff. But the voice stuff was applied over my Linux servers. So I worked heavily like with his dad and his dad's team on keeping voice over IP for a call center for our because we were AAA, so we had to be able to take calls in all the time. And our voice over IP stuff was bringing stuff in, and it was automatically recording things and then transcribing them, doing all these other things. But I was kind of in charge of keeping the servers stable and then looking at some of this stuff. And, M-Pesa is one of the he's just one of the best engineers I've ever worked with. And he's young, too. He's really young. But his dad was also really good. His dad was a voice over IP guy with us when I worked over at AAA. So I knew his dad before I knew him. But, yeah, he's really good. So, yeah, half your life is wasted on bad compression. Yeah, even more if you don't talk very often, yeah. But even when you're talking, like even if you're talking and like things are moving fast, there's a lot of time that is dead air as far as the computer is concerned, and there's a lot of compression we can get out of these systems. So look, I didn't talk about that to show you guys like maybe one person out of 100 is gonna look at that and go, man, that's really interesting. I want to go spend some time with that. Maybe that's where your career goes. I tell you guys all the time, Linux as an engineering platform can take you into music, and it can take you into signals, and it can take you into electrical engineering, and it can take I think it's a great base for all types of engineering that you guys might be interested in. Quartz One, and also I missed tomorrow earlier. I heard you do it, but I was on a rampage. But yeah, thanks for the resubscriptions and all that kind of stuff. Keeps me motivated. And man, I haven't been on for a week, so I figured I'd get on. It's also the last day of the month, so if you guys know how Twitch works, they calculate everything, like cut it off at the end of the month, and then they do some some small amount of like a pit, and they like flip this little cap at you like this. It's like a, I think I just dropped that on my keyboard. Anyways, but they like flip a nickel at you or whatever. But I'm not really worried about Twitch Pay. It's never gonna pay. It's never gonna pay the bills, but it's more fun. I actually what was I telling the wife the other day? Oh yeah, I was saying on stream the one day too how it's like, man, like if you guys know what I make as an engineer and then you know what I make doing Twitch, you'd be like, why the fuck are you doing this? Well, it's fun, right? It's like I get to find other people that are interested in doing this stuff, and then we have our little Discord where we kind of hang out and party. By the way, Discord's always free. Never going to charge for Discord. There's a monetization thing on Discord that I'm never going to hit that button because that's just silliness. But I definitely appreciate you guys coming on. I promise. Yeah, that's funny. Somebody said earlier, I don't know if it was any of you guys, if I did a bathtub stream, I'd gift 100 subs. All right, fair enough. I don't know if the wife will ever let me do that, but that's kind of funny. Somebody earlier, I don't think it was Hayes, it was somebody. See, that's the problem too, guys, is I have my ability to record what's being said is about as long as this little chat window right here. Somebody earlier said I had a sexy voice, and I thought that was kind of funny because I bet my wife would be amused to hear that. So, yeah. Voice over IP is a nightmare, but it's also, there's good work in voice over IP space if you guys want to do that. One of our guys, he goes by the name Busted on our Discord. He is a voice over IP guy, and that's what he does. So, yeah. Stream is fun, right? Stream is just hanging out with everything. Atticus is here. How's it going, Atticus? Over on the YouTube side of things. What is the market headed in regards to system engineering? Is there general gain in hiring or decline? Atticus, I couldn't tell you. I can tell you that, like, systems engineers are still needed. Systems admins are still needed. I keep hearing, like, oh, the job's going away because, ChatGPT can just do it faster and whatever. And I'm like, yeah, but ChatGPT also was helping somebody earlier, and you guys can see it in our Discord. It drew a picture, and it's like VLAN 10 going into a car's tailpipe. And you're like, well, all right, maybe. But also, I don't think ChatGPT knows what's going on half the time. So anyways, I don't think systems engineering is going away anytime soon. But again, systems engineering feeds into platform engineering, which is kind of what I do. I do hardware stuff. I do networking stuff. I go into data center. I have a data center about 3 miles, maybe about 4 miles from my house right here for NOAA. And I work on I'm back on the National Oceanographic Atmospheric Agency project. I'm actually moving over to that in the next few weeks again. But I helped build that one out here. So, like, again, this is the stuff where I show you guys, like, you don't have to know everything about this, but it's a good idea to know how to reference it. And then if you want to, kind of just be good in the engineering world, you just have to kind of understand how things work, right? How well will ChatGPT maintain your system? I don't know, Hayes. I've seen some cool applications. Fisherman put one together a while back. Fisherman is our Fisherman Guy Bro is one of our guys that I don't think I have any mods here, but let me give a shout out. He hasn't streamed in a while. Fisherman. I think you guys should follow him if you don't. He's got some really good stuff. He does a lot of AI, ML type stuff within AWS. He's actually got a cert for it, and he's got the certification for it. And also, if you go AI, ML, no, it's AWS AI. He wrote a pretty good. He was doing all these streams a while back, and then when he was done, he wrote a guide. So if you guys want to go take that AWS practitioner cert for AI, where did he? Hold on. I think it was AI ML. I was just looking at this the other day, and I meant to pull it up. Where did he do it? Oh, shoot. I don't even know where he put it. Wait, was this when Fisherman... that was when he was giving Robodom a hard time until he got a Security Plus. But then, when did he do it? I think he did it last year. He got his Certified Data Engineer Associate. When did he do that? That was later last year. But he also did... Oh, maybe he's up to 8 certs now. He did one, though. Hold on. And he put in... Don't mind all this other noise. Shit. I'm gonna have to ask him when he did it, because I think he did it at the end of 2023. Now that I think about it. Hold on. AWS. I think he called it a primer. No, he didn't. It is a practitioner cert, though. So it would have been... What's the date on this? 8/26/24. So it was... Hold on. 8/26. So he did it right around that time. Hold on. We're going to find this effing thing. He scheduled it. And he passed it. And then he knocked them all out. But then he made a really good little primer for these guys. What the hell is that? I just found it the other day. And I thought to relink it, but I didn't. Maybe put the primer before he took the test. That doesn't seem like him, though. Fisherman tends to just, like... shoot and go do them. I don't know. Well, shit. Oh wow, that was when he started taking the certs in 2022. Anyways, all right, I'll have to ask him. He definitely posted a while back. I'll make him post again. Yeah, Quartz One, if you can find it. I don't know if one of you guys minds finding it and then just reposting it, but you can just put a link to it. I thought I had linked to it the other day, but I don't remember. Anyways, Stream is Illusion. That's exactly how he's rolling. Yeah. But we try to get Fisherman doing more streaming, but then he gets busy with stuff. So he's pretty solid, though, on his stuff, and it works pretty well. But, yeah, he's definitely one of the guys to go to for this. Did he put it in presentations? No. Although he is a mod, so he could put it anywhere he wanted. These are different talks that people have came and done in our presentations channel. Where is it? Hold on. AWS. Maybe he did machine learning. Nope. That's annoying. I always lose when I try to do Discord's freaking their search, man. All right, anyways. Yeah, I thought I pinned it. I thought I seriously had it the other day, and I grabbed the because somebody was asking about something. I was like, oh, you should go study for this. And he made, what did he call it? I don't remember if he called it. Oh, hold on. We'll give it one more shot. I think he called it a study guide. We have good study guides in here that different guys have made. But did Fisherman call his thing a study guide? We have some stuff for different other study guides too. Oh, here it is. All right. Yeah, if any of you guys want this, I'll link it in the certified topics. I'll link it as the most recent. And I remember he took this when it was still a, let's download this real quick. He took this when it was still a, what's it called? Let me see, hold on. Can I just open that as a, downloads? Open with. We'll open it with Sumatra, because, oh, this reverses the color. He must have done this in dark mode. So, give me a second real quick. I'll change the settings on this. Options. Hold on. Advanced options here. We'll change this back. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And then save it. Boom. This is the way he originally wrote this right here. So this was the AWS certified AI practitioner. So if any of you guys want to go take that cert, he went and passed it. And this was his study guide for it. Like what you needed to know, what you needed to kind of understand. And their practitioner certs are all, they're all like the basic level. You need to know all the terms, and you need to know like the basics of how the things interact. Oh, hold on. Gotta go over here to chat. So he talks about Amazon Inspector, identity access management, these basic security things you always need to know. And then he starts to talk about the foundation models, bedrock and model transparency, what's going on. You need to know the different AI tools. Some of you guys have been around where I have Polly talking to us, right? You can use Polly with some of the little speaker bots and stuff like that. Super easy to get that stuff working. And then he comes down and talks about the evaluation metrics, right? He just slapped this little thing together for you guys, so you guys would know like the high level concepts. Should you go study more? Probably, but this was a good little primer for you guys that wanted to kind of get started. Yeah, I might even go. Yeah, the cloud practitioner is a good one. Enzo Bear, I don't know if you know, but somebody was talking about doing their solutions architect associate too. So I know some of you guys have been looking at getting into that stuff. So yeah, or some of you guys that want to know more about solutions architect associate, there's a bunch of us on the server that have that one. And then my brother John just passed his solutions architect pro last month, and I got mine, I think I got mine in 2023 now, so it's been a little while since I got my pro. But my stuff's still pretty relevant if anybody needs to work on any of that. Still stand by the mantra, the philosophical statement, my name embodies time is your greatest real adversary in life. There's never enough time. Yeah, fair enough. There's time, you do run out of time, that's for sure. Yeah, tomorrow, you can definitely go for your associate. One of the things, by the way, I think I've told you guys this, when I study up for my certs in AWS, of which I have 5, when I study up for them, one of the last things I do, like when I feel like studying's all done and I've got a couple days left before the cert, I just watch reInvent videos on like 1.75, and I just blast through, like when I did Solutions Architect Pro, I listened to everything about relational database service, because I was like, I know they're going to ask me something about replication between regions, and I know they're going to ask me something about this, and they did. Of course they did, right? That's a big part of Solutions Architect Pro. But because I was hearing how architects were using relational database services and the new things that were coming, those are the type of things that show up on the test. Also, I always go read the frequently asked questions pages about things. And I'll tell you guys, like when I did my Solutions Architect Associate, there were a couple things I had never heard of. And I was like, oh, I'm going to go look those up. And I looked them up. I passed it the first time, but I went and I looked up things that I legitimately did not know. And the questions that I got asked were directly on the frequently asked questions pages. And I'm like, well, shit, I wish I had just read this. That would have saved me not knowing that one thing. So anyways, I don't know, something to think about. All right, so what happens at layer 6? What happens at layer 5? Again, windowing and flow control. We talked about this a little bit. Windowing is how much we're going to be able to send before we require an acknowledgement back. That is directly a TCP concept. So layer 5 almost does not apply in any way to UDP, right? Flow control is the control of that windowing. How big are the windows based on the information we know about the connection, right? That kind of stuff. All right, layer 4 protocols, we start to get into TCP and UDP. We have 0 to 65.535 are our allowable ports, right? And they can be connected to on a device that's using a TCP IP protocol stack. So TCP is connection oriented, UDP is connectionless. In a connection oriented system, there are always these 3 phases of communication. There is an establishment phase, which is the 3-way handshake. There is a data passing phrase. Data are passed in sequential order. And then there is a breakdown phase. Those 3 things must happen in order. Data must be passed in sequential order. So meaning you get the first segment, right? Because we're dealing with segments here. You get the first segment, then you get the second segment, then you get the third segment, then you get the fourth segment. Oh, did you get the 6th segment before the 5th segment? Nope. Get them both. Gotta resend everything in that window again. That is how transmission control protocol works. I tell people it's a lot like a train. Now, you might never think about this because it's kind of morbid, but if a train is going along tracks and it left and there were 17 cars, and those 17 cars, when they get to the far side of the train station, they better be in the same order. Because if they come in any other order, everybody on that train's probably dead, right? Right? It's the Mugen train, right? What's that from? Who knows what that is? Yeah, Enzo Bear, you might have to send it on Discord. I don't think I have any mods here that can give you the ability to send that. Yeah, you just see the stars. Drop it in the search channel if you guys have something that you want in there. Okay. Anyways, connectionless, shotgun it over. There's no 3-way handshake. There's no data passing in sequential order, and then there's no breakdown. Now, if you capture the full TCP connection happening inside of like something like Wireshark, you will actually see. So if there's a SIP, now SIP and all of this is going to be UDP, so we're not going to get any of the TCP information here. So I'm going to go jump over to one of my other, let's see if on one of my longer test PCAPs, pretty sure this one will have a full TCP connection. And I can come down here and I can look in the flags. In this case, it is an acknowledgement and a push, but it is not a SYN. It's not a SYN, SYN-ACK, ACK, right? So this is not the session correction. So this is probably something that has already been started before I started listening. So then I come down and maybe I come start down here and I say, okay, what do we got here? This is an acknowledgement. This is an ACK right here. So maybe I need to go up a little bit. Here's an ACK as well. I need to go up even further. Let's see. By the way, you can also go here and you can say follow this TCP stream, and then you may be able to go up to the start and you may be able to find the start of that communication. No, we're not able to find the start. It must have started before. But the point is you start to learn how to use these tools and you can go find, this is all of the TCP that was captured in this whatever time frame, time window I was listening on this network. I didn't capture the whole communication. So I don't have everything. All right. But I do know that it's TLS and something was happening with TLS in here. There was acknowledgement and pushes happening, right? So the point is, all this information is passed in the header that is put at the transport layer on the TCP header, right? And the TCP header looks like this. So here, this is the protocol data unit datagram segment for a TCP header. Here is the IETF RFC for that header. And this right here is a source port, which is 16 bits long, a destination port, which are 16 bits long. Say, Scott, how do you know they're 16 bits? Well, it's 0 to 65.535, so that is 16 bits. All zeros through all ones, right? Same thing that we looked at in the addressing, it's just there. TCP has a sequence number that's 32 bits long and an acknowledgement number that's 32 bits long. So you can come back over here and on any one of these, they're going to do something interesting here for us. They're going to tell us, here's the sequence number raw. This is the actual number that's in there. But in relation to the stream of data, it's sequence number 0. It's the first, right? And the acknowledgement number, in this case, is both. Here's the raw number, because it's just randomly started at whatever. But the raw acknowledgement number is 1. This is the first one. So there. Oh, Enzo Bear, you're still waiting on that? Yeah. Well, I mean, I guess the best thing you can do while you wait is pick up something to study, right? Find something that's interesting to you. I tell people do as much Linux as you can. Pick up an instrument, do something, study. Just be as ready as you can for whatever you're going to be doing. Data center jobs, I mean, I work in a data center sometimes. I never know what I'm going to do when I go in a data center. Guys, I bring this with me every time. You guys probably think I'm kidding, but this is always on my belt. One of these guys. I can open it with one hand. Little Gerber. One of the best things ever. And the reason I like being able to open it with one hand is I can reach back while I'm holding something, do that, do whatever thing I need to do, straighten some freaking Solaris rack or whatever. Solaris, so back in the day with Sun, I swear Sun used to build stuff to catch and cut your hands in data center. If somebody found like some memos where they said they did that stuff for real, and I would tell you I'm not surprised. Like I really do believe that they were trying to hurt us in the data centers. Some of those damn racks, I'm like, there's no way this is the easiest thing somebody could figure out. But anyways, this is your header, and you can go look at each individual piece and you can learn more about it and stuff. Now compare that. Look how long that is. Also, what if I stopped talking right here until I said, hey guys, can somebody acknowledge you can still hear me? And then I just stopped, right? And then like one of you guys was like, hey, I can hear you, right? And then I continued on. Or I actually like sat here and waited until somebody typed. That would be very slow. Don't you guys think that would slow down this whole process of us communicating? It would. So sequencing and acknowledging increase what we call the overhead on the connection. There's more time for communication to occur when, you know, like let's say you're talking on your phone with your mom or something, and she's like, are you listening to me? And you're like, yes, Mom, I'm still listening. But she does that like every 30 seconds. That would be a nightmare, right? Like that would be terrible. So UDP is not that. So look, this is all that. So 32 bits across, 32 bits across, 32 bits with different things going on. Here's your SYN, SYN-ACK, and ACK. When you're sending things, you can go look at them in your Wireshark. And then the UDP header. There's a source port and a destination. There's a length, so you know how long it's supposed to be. And there's a checksum built in to make sure that everything is there when it gets to the far side. So, if I were to ask you here, which of these do you think passes data faster? Which one do you think it is? This one with this is a big behemoth. This connects and it does all these things. Yeah, this one's fast. So, knowing that this one's fast, but it doesn't have all the error correction, it doesn't have the acknowledgments, and it literally can't tell you the order of the things coming in. There's no real way to know that here. Yeah, UDP. Which way do you think we communicate, like here or in a team session, or the protocols like real-time transport protocol and secure real-time transport protocol that govern a lot of the voice over IP stuff? How do you think we do all that voice over IP? What do you guys think is being used? This guy or this guy? As you go to inform that decision, I'm going to tell you guys something else. In call centers, we were talking about codecs earlier in call centers and how data gets to you. If a packet of data, right? So if we're chopping your voice up in data samples and sending it, if a packet of data gets to your ear 1/6 of a second later than it's supposed to, you might as well throw it away. So knowing that, what do you guys think it is, UDP or TCP? It's definitely UDP, guys. Yeah, we shotgun this data as fast as we can across with UDP, and we let the upper layers sort it out. So the real-time transport protocol above is sorting out all this UDP. But yeah, when you guys talk on Teams, when you talk on Slack, if you get in a voice huddle with your buddies, or at work and somebody calls you and then blasts bright stuff in your face, right? All this kind of stuff, like like I'm always pulling up Wireshark and it's all bright. All of that stuff that happens is what am I thinking? It's all done with UDP, all of it, and then it's like we assemble it higher. It's kind of like the old I'm just gonna empty the mag and let whoever sort it out, right? That's the idea, is like we just shotgun the data over as fast as we can, and then the upper layer protocols reassemble it as it gets here. And if something comes out of order from UDP, chuck it. It doesn't need to get to my ears, because then we start to get jitter on a line. You don't want jitter, you don't want delay. So you just shotgun it all over as fast as you can, put it together, and if there's a piece missing here or there, doesn't matter. Back to that thing I was saying about 1/6 of the data. If it comes, a sixth of a second late with data, you might as well chuck it. There's another concept that they found where they started to do samples with this, and you can go look these up if you want. But they said, well, wait a minute. When I'm talking to you or we're on a phone call, how much of this can I drop and that person still understand? And they found that you could drop as much as like 40% of me talking to you right now, and most of you would still understand what I was saying. Most of you wouldn't even notice. Like you would still be able to hear. Hey, thanks for the follows, guys. Hopefully this stuff's useful to you. So where I'm going with that is the idea that stuff always has to come in exactly that order, and that kind of stuff. The TCP way of doing it, where everything comes over, it's not that important. By the way, some of you may be wondering, is this available on the Discord? This is all up in the Discord, all this. And there's also another recording that I did that was just specifically this. As I've been talking this time, I've been going far afield, and I've been pulling up the Linux stuff, and we've been talking through some of these other things as we go. But, I have a talk that's just this stuff. So you guys, hey, thanks for the follow. I wonder if I'm getting rated. Sometimes when you get rated, before you find out that you're rated, people will start following you. So maybe I'm getting rated by somebody. I don't know. TCP is 32 bits and UDP is 16, so TCP is twice as slow. Enzo Bear, I wouldn't say that's true necessarily. I would just tell you that this is, there's more control and there's more things that have to be checked. You can almost think of it like, let's just say I took this water bottle here and I got a whole bunch of water bottles here in my fridge, and you guys were like, he's a madman. I just started chucking them out the door right there. And you're like, he's a madman. But if I was just chucking them out the door as fast as I could, you guys would be like, well, I hope on the other side they're catching them and putting them back in order. But what if I stopped for every one and I went like this and I read the bottle and I went, okay, this, and I stamped it with one, and then I chucked it. And then I got the next one and I went, and then I stamped it as two, and then I chucked that. And then I waited till somebody called back and said, I got the first two, send the next two, right? And however many they could catch is kind of the windowing, right? This is a lot of control, but not speed. This is speed, and then we allow an upper layer protocol to put things together. There's other things that happen with error checking mechanisms, like at layer 2 with frames. We used to use a protocol .x.25, and x.25 used to do the same thing where it would check in all the time. And then Ethernet 2.1, so Ethernet 1 at layer 2, because it doesn't care, it just launches data. It literally just launches data, and the frame, you can check it on the far side as you get it, but there's no at layer 2 nowadays, layer 1 and layer 2, we don't care anymore. We're gonna let the upper layer protocols assemble shit. But back in the day, x.25 used to have this back and forth, and guess what? It was slower, but it was also needed because lines 30 years ago weren't nearly as effective, and you did have back in the day collisions, and you had all these other craps that don't really come in anymore. Anyways, thanks for the follows, guys. Hopefully this stuff's useful to you. We're just doing Linux, and I got asked earlier. There's a kind of high points channel or points redeem for our channel that has to do with you can make me talk about anything I've talked about before, and I happen to be a professor for networking and systems engineering, so I got asked to kind of give my primer on this. So that's what we're doing. All right. Well, I guess asked to do networking, so that's what we're doing, networking. All right. At this same layer, transport layer, we have transport layer security, TLS. So this is transport layer security, and it is our data in motion. So you will hear in the systems world, so this is transport layer security. Right? And data in motion is one of these concepts that comes up in the cloud a lot. At this layer, what are HPC admins focused on, or what do they care about? Tomorrow, I do have a different talk on like the HPC stuff. We talked about that too if you guys wanted. But data in motion is this idea that anytime the data is not at rest and anytime the data is not in use by a system, it's in motion between systems. So we use a thing called TLS. TLS, you will often hear people talk about SSL, which is Secure Socket Layer, right? And SSL is not really used anymore. We now use TLS 1.2 or 1.3. And then you've got this idea of a handshake where a client wants to make sure the server is who it says it is. So it uses a method of taking the public key of the server cert that it gets from someone it trusts. There's a trust built with typically a CA, which is Certificate Authority. And the client will download the server's public key. There's a big site out there that's very popular that does like data flow diagrams, and they show that the server sends its private key to users. That's absolute silliness. The private key never leaves the server. A private key is never sent from a server ever. That's like the silliest thing I've ever heard. And there's a very popular data like drawing company. They're big on LinkedIn. People are always sharing their crap, and they show that they send their private key, and I'm like, that's not true. Private keys are never sent anywhere, right? But anyways, a client can take a public key and it can encrypt a message right here, and the message can be like hello. I don't know. It could be whatever. And the only person that could decrypt it is somebody that has that server's private key. So they can use a public key to encrypt a message, and then they can prove that they are who they say they are by sending back the decrypted message. They're the only ones that can decrypt it because they've got the server's private key. We'll look at that here in a little bit. Once they do that, though, then they come down here and they calculate a symmetric key, and they do symmetric key encryption beforehand. So if this up here is asymmetric, I think that's spelling asymmetric, right? If this is asymmetric already, this is something we talk about sometimes, then why do we calculate a symmetric key and use that? Why do we use that key from then on? Why is that? Does anybody remember, or was anybody here when I said it earlier? Why must IPsec such some? Yeah, fair enough. But why does this key? Why is this a symmetric key? It's like the worst K I've ever drawn. Why is this symmetric? Why do we care? And why don't we just use the asymmetric key? We know that they're who they say they are. Why don't we just keep using this? And this one is 10 times the processing cost. Right? 10 times the processing cost. Yeah. So we were talking this earlier too about how a lot of times we won't even do this directly to a server. We'll do TLS, transport layer security termination, to like a load balancer before it gets to the server. So this server is not spending all its time doing TLS stuff. The asymmetric key is you can revolve asymmetric keys if you want. You can do that, but then you have to use your public key infrastructure and regenerate things. And you should generate these every year or every 2 years, depending on your key schedule. By the way, if you want to know the AWS, or not AWS, the DoD standard for key management is NIST 800-57. So I'll link that to you guys if you want it, because NIST 800-57. And it is the recommendations for key management right here. And then you go here, and this is the download. So this is the PDF. So if any of you guys want to read and go to sleep tonight, really good, read this. Symmetric is faster by 1 order of magnitude because there's less processing power involved. Yes, 100%. So we use that key. All right. So, so here was this. We'll go down one. PKI is commonly known, so public key infrastructure, commonly known as secure socket layer or transport layer security. SSL and TLS are 2 public key encryption protocols commonly used to encrypt communications across the internet, right? They're well known. They're well generated. Crash Systems, I just regenerated a key using ECDSA, which is elliptical curve DSA. I forget what DSA is. And now I'm finding all the old stuff that doesn't support it. Yeah. That'll when I do STIGs in a system and I force a certain type of key, guys, there's there's so much to it when we talk about like engineering versus administration. When I engineer something new, I get to build everything new and clean. But when I build something and then I try to like take this, new security standard and go lay it in like a swamp of just this, it's called like a miasma of what's around the servers that are there, you'll find all these things that don't work with it anymore. It's guys, it is very difficult if you have a server that's 5 years old to bring it up to a security standard. It is almost impossible. I would say it is. Hold on. This thing's frozen. Is it better? Hold on. Are you better? Subtitles? Are you going to work? There we go. All right. It's so hard to bring a server up like that because you will break so much crap. It's better to just, like almost universally to just build a new server and put it in place. So like for me in my home lab here, right? Some of you guys are familiar with the home lab environment over here. By the way, this is still available for people to draw in if they want to. And if you want to know how to get to this, it's in the Discord under, where did I put it? I think I put it in off topic. Yeah, nope. I put it in Twitch, YouTube questions. So if you come in here and you click on, what the hell? I put in the schedule. Hold on. I don't know where I put it, guys. Yeah, it's here. This is the Excala draw that you could draw in right there with all my stuff if you wanted. So, Z-Love, yeah. I mean, it's the idea. Yeah, breaking a server and getting it back the way it was working, very difficult. I mean, you have to, sometimes even down to bare metal. But in my home system, I've got this P01 Jumpo 1 box. Some of you guys are familiar with it. And this poor server, anybody know what version of operating system that is? Some of you guys are just going to shake your head and log off when you hear the version of the operating system. This is my jump box. This is where I jump everywhere in my home lab, right? He's a bit older. I mean, CentOS 7 is very long in the tooth. CentOS 7 is CentOS is no longer supported, but CentOS 7, man. I don't even think I can update this guy anymore. It's bad. It's bad. I need to rebuild him. And when I rebuild him, I'm going to build him. I'm going to put him to a STIG standard. And then I'm going to put him back in place of doing all this other stuff. And hope that all this other stuff still works. It should all still work. But yeah, some of you guys are in here. Somebody's wandering around up here somewhere. Impeccable Lemur. It'll just give you a name if you don't put a name in. But then I can save this, right? I can just save to the current file. And it'll save that down. Hopefully nobody's put anything too wild in there. No, nothing's too wild in there. But then now I have this saved because I had forgotten to save it the other day when I pulled out. This was all planned the other day, and I didn't have it set up right. Enzo Bear, is yours still here? Yeah, I didn't delete anything from anybody. No, your stuff's all still here. Yeah. Here, you need the link again? Here's the link. Oh, on the Twitch side, you have to pull it out. And on the YouTube side, you guys can just click it. But yeah, so I have this saved, so I don't care what you guys do to this drawing. But if you guys have never used Excalidraw, you guys can actually go in there and you can draw right over somebody's thing, and then you can save it. This is the most important thing, is you could save this. So a jump box tends to be, it's 7. It's a server that we use in an environment that's persistent, and then we can come into it from the outside, and then we can jump to other places. So let me show you this. This is my home lab server, right? This is P01 Jump 01, and I've got a bunch of different sessions across the bottom. Whoops. I can go here. Watch this. I can jump to the different sessions. Do you see that? So I'm going to show you something that for some people that aren't like as much like administrators, you're going to be like, oh, don't do that. You're going to lose everything. Watch, I'm just going to close this session down. Screen's gone. Now we just got this stuff. People over here drawing stuff. And I'm going to open a new putty session to that box. So watch right here. In my home lab. Where's my home lab? Here he is. Right. And I'm just going to jump into that server again. If I remember the password right. And now I'm going to be in a brand new shell in that environment, right? And then I'm going to say screen-ls and then screen-r. And I'm going to reconnect to the screen session I was just in, doing whatever I was doing in that environment. So this is what this is this is a persistent thing in this environment. I can take my laptop here. I can unplug. I can go to Mexico. I'm going to Mexico in a few months. I can go to Mexico. I can jump back into my home server, and I will be right here again, like this. And with my customers, like for people that I work with government systems and stuff, I can jump into their systems and have a persistent running connection like this of whatever I'm allowed to do within like the rule sets of their environment. Sometimes I have to jump in and do stuff, and then after a certain amount of time I get timed out or whatever. But I can leave this no-hupped in the environment as long as the rules don't stop me. And there's administrative controls and there's technical controls. So you guys that do security, you know the difference. If you don't technically control me, I'm going to do whatever I want. But anyways, I digress. But the point is I can do whatever I need over here. Oh no, we got wiped. It's fine. I don't care if people wipe this because I have a copy of it. But you guys can start drawing in here whatever you need. Oh, I think somebody might change the color. Oh, that's what it was. So I'm going to get rid of my stuff. And, oh, so you guys that jump in there, you have to change it to dark mode because when you guys jump in, you're probably in light mode. So you got to jump into your own dark mode. I can't set your system to dark mode, but I look at mine in dark mode. So that's that. Anyways, that's what a jump box is. It's just a way to jump into a server or into an environment, and then that stays persistent even if I take this laptop and go somewhere else. It's like a game changer in the administration world because could you imagine it's like 5 o'clock, you want to get home, you want to like take your shoes off, you want to, this obviously I'm talking back before COVID. Now we just all work from home and, you know, but back in the day, I'd be working at like AAA and I'd be, you know, doing my stuff and I'd have something that was going to take another hour or two to run. But I kind of want to monitor it, but I don't want to be at work anymore till 7 at night. I just want to get in my car. I only lived about 2 miles from work, maybe not even 2 miles. And I would just so what I could do is I could take my laptop, go home, reconnect, get back into the VPN, reconnect to my jump box, which was persistent. It's a server sitting there, and just jump and be on the same system. But now I'm home watching Netflix or doing whatever. So yeah, having a jump box, having a server in an environment that's kind of it's almost like your little home base. And then we come into them through our Bastion controls, right? So, whoops. So we have like a Bastion system that I've set up where you guys can jump from the internet into the system. It's not hard to do. You can go get in the Discord and figure out how to do it. We got a Linux Systems admin course where I'm going to have you guys down in the Rocky servers, and you guys can jump in there and do whatever you want in those environments. And then when we're done with them, we just wipe them. So this is one of the Rocky boxes. These are all the servers that are out there, but all the Rocky boxes are there for you guys to do whatever you want with, you know. And then if you destroy them, I just rebuild them and they're fixed. Like it's like that. So it's the simplest thing, but it just takes some time. It just takes some time to build this stuff, guys. This stuff, if it looks complex, It's only because it's been worked on for a long time. By the way, I didn't draw those guys up there. One of the guys did. People draw stuff all over here. I don't care. But look, a live frog is there, whoever that is. So you guys can add to this drawing. You can. People have added their own stuff that they were working on, right? Obviously, we have copies of this. I wouldn't share it if we didn't have copies. Somebody had added this over here. This was, they wanted to, CGNAT is a bit, so they wanted to develop what their system was going to look like. And look, sometimes, right, we just want to go and start building stuff, but sometimes we can come in here and kind of figure out what the systems are doing as well. RDP into a laptop at work and then access servers from there. It's exactly the same thing. It's 7. Some people in like AWS, there's actually servers that you can jump up into through like their, what they used to call that service where you'd be in and you'd be on like a Linux box, but you were just in your web browser. It's the same kind of concept. And then you could give it identity and access management to be able to connect to different servers and stuff. It's exactly the same kind of concept. Yeah, so that laptop, if there's a physical laptop somewhere, cool. But nowadays there's also what do they call it? What's that infrastructure that everybody builds out? It's a virtual workstation. What's that term? Somebody tell me. Somebody knows what that term is. Eric said, as a noob, what do you use to manage all your Linux machines? So I have a tool called XCPNG. This is to step back for a second and answer that question. All of my servers, I have 4 physical servers here. They are pretty beefy servers for the most part. They all have about 128 gigs of RAM in them. But they are then virtualized as hosts. They are host operating systems of XCPNG. Inside of them exist all of these virtual guests that then are configured through a tool called Werewolf. And that's WAREWULF. I know it's silliness, but it's what it is. It's Werewolf. This is how all my servers are managed, and then I configure them, and once I get them running, I go into them through, let me get that out of there, it's a different system. I configure them and get into them through PuTTY. I jump into my jump box, that's my jump box here, and then I jump over to like the Werewolf node, and then this is each of the individual Werewolf nodes underneath that one primary node, right? And then I was working on all this stuff the other day because we were stigging some of the boxes. I need to put, one of these days, I need to put together like just a Werewolf training that just shows you guys kind of from start to finish how to build and configure Werewolf in your system. No, what's the name of that? Hold on, hold on, this is going to bug me, guys, sorry. Because my brain doesn't work so good anymore. I'm just kidding. AWS virtual machine, virtual workstation. What the heck's the name of that? It's workspaces, but there's a term for it. VDS, VDP, VD. There's a like an industry term for this. VDI, virtual desktop instance. VDI, virtual desktop instance. That's what it is. Yeah. So they call them virtual desktop services, but yeah. We would talk about like give somebody a VDI and then they could jump in and then get to all the different stuff. Yeah. And guys, I tell you, you don't have to build a home lab out. Can I show you guys one thing real quick? Some people have jumped in and maybe you guys haven't been around before or don't know all the kind of stuff that we do. The group that I kind of run is called the Professional Linux Users Group. It is an engineering group for people who are hobbyists and Linux engineers and Linux enthusiasts that want to help other people get into doing this stuff professionally if you want. That's the stated goal of our group. That's what we do, right? We run it through Discord. We have like almost 3,600 people in there. You guys are welcome to hop into the Discord whenever you want. Does XCP work with Windows? Oh, absolutely, Eric. Yeah, if you wanted to run Windows inside of that, you could 100%. Yep. But one thing that I show you guys, and this is going to be bright for a second. Killer Coda is the best thing on the web. The best thing on the web. I'm going to link it to you guys for learning systems. You don't have to build anything. You don't have to have a home lab. Let's say, hey, Scott, I want to learn Linux. And I would go, well, right here, Powaz has 20-something labs and then a test that'll teach you about Linux. Free. This is all free. There's a guy that goes by Het Tanis. down here. It's me. And I have a bunch of labs down here too. That'll teach you 28 labs that'll teach you about Linux, right? We go through labs on Sundays a lot of times. And it's like, look around the Linux system, check kernel and packages, disk, IP information, all this stuff. Come down here, you get into security, right? We start to look at users are trying to log into your systems and what's going on, right? Then I also have a tremendous amount of Ansible. We have 21 Ansible labs because Ansible is automation in the system, right? And this is, I have built my career around automation, right? I'm a Linux engineer, high performance compute engineer, but the reason people hire me and like me is because I can make 1,000 servers look exactly the same. That's because of this tool right here. I can do it with other tools too, but this is the cleanest tool. Ansible is by far the king. There's a whole cult of Ansible. You do a little of this and you go, I see why they're drinking the Kool-Aid. I see why that is so cool. Because it works. It works and it works well and it tells you what didn't work. And, you know, watch this real quick. I'll be on this box real quick and I'll just say Ansible all -m shell -a cat. Let's just say proc cmd line. I need to know all of the servers and their command line interface and how they were booted as they were called, and maybe I just wanted to know their kernel version. I could check that here in a second. But for all those systems, all 44 of those systems, I'm going to get a response back that's going to tell me, one, the color tells me that I connected and it's good. Two, if something errors out, I'm going to see it right away, right here. But like this is just a clean tool. I can pull this information out and I can look for things. I can search for things. I can do all kinds of stuff with Ansible, right? Watch this. Let's see if we wanted to verify, we wanted to test and understand for sure that all of our systems had the same kernel, right? And we could do this. Those are all built from the same compute image, so I hope they're exactly the same fucking kernel. If they're not the same kernel, man, something's wrong, right? But anyways, I can reboot all these boxes and watch them come up in my environment. I can do all these things, but again, it's because I understand these simple things. I tell you guys all the time, and some of you guys, as you stick around, are going to find out this is true. I do all kinds of stuff that probably looks like it's smart and fast. I assure you I'm not that smart and fast. I've just been doing this a long time. And a lot of this stuff I built over time, right, to look like it does. But it all starts with, this started a couple weeks ago. The guys asked me to draw this on, somebody said, hey, will you draw that in our meeting? So I think like 2-3 weeks ago we had a meeting. And I said, yeah, I'll draw out what my home lab architecture kind of looks like. And this is kind of a logical flow diagram of how everything works. So, same client that owns, libcrypt and systemd because ChatGPT. Oh my God. That's, yeah, people will do anything to not learn Linux too. That's for damn sure. All right. Where are we at though, guys? It's only 7 o'clock. I've been streaming for, 4 hours and 10 minutes now. This is a long one. But again, the goal of the group is to get you guys down in the Discord, not because I make anything off of you guys. Discord is free, right? Discord, look, it's popping right now. People are hanging out. They're telling jokes. They're doing all kinds of stuff. We've got events coming up. I always try to show you guys. Writer's Room is tomorrow at 12. That is 12 o'clock my time. If you look at it in Discord, it'll be in the top left if you're on a computer. It'll be on the top right if you're on mobile. So I do a fair amount of Discord on my phone so I know where it is. But the events, the Writer's Room tomorrow, Treasure will talk to you guys about building. And some people want to get better at writing and they want to do some other stuff. This is actually for our Linux Systems Admin course. We put together a course and these guys are organizing it into a book. It's going to be a free book. You guys can just download it off the web. Then I'm going to talk tomorrow a little later in the day, and that's going to be about that's just our weekly meeting. Come in, talk about systems, talk about what we're working on, talk about job interviews. Some people have been doing job interviews, trying to get jobs, that kind of stuff. And then starting March again, we're going to do our 16-week Linux admin course. This is free. This is also what that book's about, right? All of the material is in Discord already, but I think the guys are right. Like if I tell you, hey, go to ProLUG projects and download all this stuff, most of you are going to be like, I ain't doing that. But if I just give you a link to the book and say, here's the 16-week course book, decide if you guys want to come and do it, right? It's free, but it's also going to be it's much easier to go to one link and just download everything in a PDF, right? Than this. But this is how we built the course right here. Was we did all of this stuff, and I think the people that learned it, there was 208 people that signed up to come through it. Again, free. They just said that they were coming, and we had like 8 or 9 people pass it, and then they got a cool little certificate. But you guys are welcome to go in there and you know, hang out and talk shop and talk with other engineers, talk with all kinds of people smarter than me, because I've got a skill. I've done good in my career of working well with smarter engineers than myself, and just kind of getting to hang out. And for some reason, people always think I know what is going on, but you know, when I'm in meetings, I never know what's going on, but everybody always thinks I do. So, all right, we got to this as far as SSL and TLS. It's funny, every time I do this talk, I make it near the bottom and I never finish it all. But I'm probably going to get off of here soon, probably find something to eat. And then if I do hop back on later, we'll just be building labs. If I do hop back on for stream or whatever, I'm just going to build labs or whatever. But I will for sure be down in the Discord hanging out like I normally am, just posting memes and stuff. The goal has always been for me, I jokingly say this, but it is true. The goal is to have the memes and jokes so that I can farm the memes from everybody else, that I'm not the one that's always putting stuff in there. So there's that. Anyways, there's the new Linux sysadmin course is starting on March, I think it's 22nd technically. But you guys can, Saturday, March 22nd. 16 weeks. It's a big time commitment. About 100 and, if I had to guess, about 140 to 160 hours, because it's almost 10 hours a week of time that you have to put into this course if you want to, if you want to get stuff out of it and you want to pass it, right? So anyways, that's all available to you guys. You guys are all welcome to hang out down there. There's a bunch of voice channels. Sometimes people are down in there doing stuff. If you see me, like if I'm building stuff out, I'll be down in one of the building channels. Sometimes people are gaming. One cool thing about this, I don't know if any of you guys use Discord, but if you open chat, you can always see what the guys were working on. So you have all the old chat here, lots of memes and stuff. But if people are talking about interesting things, a lot of times it's in there. We have a bot that Fisherman runs, and I want to actually get him to do something with this, where when you go here, hold on, you can ask the bot, what is the kernel in Unix, right? And it'll tell you about the kernel. But there's another thing about the bot. I want him to have it aggregate up all the messages, because it's always listening. If you use the name Scott, it'll call you Scoot, or it'll call me Scoot. There's some other ones. If you say hi, it'll say hi to you. If when you join the server, it'll welcome you. So that's all kind of cool. Yeah. What happened to the best 25? Yeah, Enzo. Yeah, I've been talking about this for a while. Yeah. But this is look, like this stuff. I learned it over time. I try to make it available to you guys. This is all up in the Discord, and again, I have a fully recorded talk of this from start to finish. So even though we didn't get to everything today, we've gone through this before, and it's available for you guys if you want to see the individual pieces of this. So all right. We'll discard our ink annotations. I don't worry about that so much. All right. Well, let's go with, I'll probably drop off of here. And again, if I do hop back on later tonight, we're just going to be building labs. I've got a bunch of notes over here. I got a bunch of labs that I need to build out for you guys on Killer Coda. I want to get us over 100 labs. We're at, I think, about 63. If you include Fisherman's, I think we're at like 67. I'd like to get us up to like 100 labs, and then I also want to get some more security ones in there. I have some more cool security stuff to show you guys, and I think all this stuff I think it's all attainable for you. I think all of you guys can do it. You just have to start working on this stuff and making it there. Need a hot tub stream goal for 100K. Enzo Bear, I'll put something fun for 100K points, but I don't think it'll be a hot tub stream. Well, hold on real quick. How's Ranger doing? I can make you... that would be terrible. I'm not even going to say that. I was going to say, because Ranger sheds so much hair, I could make a little hair doll of Ranger and send it to people. I would never do. That'd be fucking gross. But there's Ranger. There's my dog. He's good. It's getting dark out. Yeah. I've been talking for a long time. He's had dinner already. I already fed him dinner, but I'll go give him a treat and then I'll go grab some food. Ooh, I know what I want. I know what I want tonight, guys. I don't. Tomorrow, you know, I used to do a lot of gambling on here with, yeah, everybody loves Ranger's like, well, one, he's a really good dog. He's a really good guard dog. He's just old, man. Like, he has a hard time walking around. And I'm pretty sure he's lost half the time. Like, he doesn't even know where he is. So, well, I'll tell you, earlier I went and got a package from out front. So Ranger came around the aisle of the house, and he was looking where the door was. And I came all the way around into the kitchen, and I was looking at him, and he didn't turn back at me. I was like 8 feet from him. He's a dog. He should know that I was there. And I was like, Ranger. He didn't turn. I go, Ranger, are you okay? And he, like, looked around, and then he looked back at me, and I'm like, oh, his hearing's going. That sucks. Because he's a good dog. But there's pictures of Ranger all up in the Discord as well. So we like Ranger dog. If you guys are in the Excalidraw, you can save a copy of this. When I close it down, it'll still be open. But like the sharing, even if I stop the session right now, you guys will still have a copy of yours. So then you can save it. And I have other Excalidraws that I've done for other topics. One other thing about Excalidraw that's really cool, you can run it inside of VS Code. So if you have other tools that you like, also Excalidraw is open source, so you can run it on your own server locally. So if you're like, I don't want to draw anything out there, I don't trust them, you can draw it locally on either VS Code as an extension or on your own Linux box if you want to, right? This is like our monitoring architecture, and we talked about this. I have a whole bunch of labs on this stuff, but all right. So let's go find somebody. I think he does have dementia, Enzo Bear. Yeah, I do. He's slow. He doesn't respond well. He's never been aggressive with anybody, and that's good. But I worry about him. I don't want him to get, because he's a good dog. He's a good Ranger dog. All right, let's go find somebody to raid on the Twitch side. On the YouTube side, I got nothing for you, unless you want to come hang out in the Discord, and then we'll be hanging out there doing this. So let's go hit Clonk. We'll go hit Clonk. If you guys know him, our raid message will be do all the Linux. So I appreciate you guys coming by, and I will talk to some of you guys later on tonight or for sure tomorrow. Take care, everyone.